Here I have two gouges designed for peeling. Peeling and exposing side grain. They're not designed to work with end grain or to expose end grain. The gouge to the left is a spindle roughing gouge, and that's ground at 40 degrees. The gouge here to the right is a bottom bowl gouge. I developed this gouge to complement the 40-40 gouge when I'm bowl turning or platter turning. But instead of the bevel being 40 degrees, I've got a 40-degree relief angle here, and I've got a bevel somewhere between 50 and 70. Deep bowls it's 70, shallow platters it's 50, and somewhere between the two. The lower the angle I work with here, the better it cuts. But this is not designed to work on a spindle turning block here, so we're going to put this to one side. But however, if you look at both of these, they are very similar in their actual design. They're U-shaped gouges, except the spindle roughing gouge has a tang and is not suitable at all for bowl turning, and the bottom bowl gouge doesn't have a tang per se. It has a strong round bar. This is a 3/4 inch, and this one is 1.5 inches. However, one is designed for spindle turning, one is designed for bowl turning, and I'm going to demonstrate this particular one in action, and we'll come back to the bottom bowl gouge later on. Here I'm going to use the spindle roughing gouge to take this block of wood down to the round. This is a 4-inch square piece of ash and a 40-degree bevel on this particular gouge. This gouge does not need a relief angle around the back of the gouge or a secondary bevel. Now on this particular piece, we're going to be taking this down the round in a peeling format. We don't want to deal with any end grain because this tool is a specialist side grain tool designed for peeling only and exposing side grain. It's never designed for peeling end grain because the wings are too far forward, so it can't interact with end grain in any manner. Now ideally I've picked a handle that is long enough here, but if you've got a set handle on yours, you have to live with what you've got. So I picked a slightly longer handle so that when I stand in position to use it, my body's somewhere towards the middle of the handle, so I can push and pull the gouge back and forth to get a nice long cut. Now the setup here is quite simple. I've set my tool rest height at what I call standard height, usually a pencil flat pointing through the middle would be good. I'm cutting a parallel piece, so I've set my tool rest parallel and not too close because I need to be able to get my gouge into position before I start the cut. So into position means it's actually physically on the tool rest. So I've set those 3 parameters on the tool rest. We'll check our speed now. So checking it's 100% clear, we start slow, we build up. Now a particular piece like this being 4 inches square, we could probably run it at about 1600 RPM, but not much faster, not till we get it down to the round. And it sounds pretty fast at that, but we know we're good. Now before I do the actual cut, remembering we don't want to deal with end grain. Now if we start in the middle of the piece of wood, right in the very middle, either direction is end grain. You'll get a little bit of a wall of end grain. So let's demonstrate that to start with. However, the volume of end grain, if you make it too big a cut, too deep, then the volume of end grain becomes too great and the tool becomes pulled by the actual end grain. So we want to keep, if we start in the middle, the volume low and going sideways. Now, ideally, as you can see, there's always some end grain exposure, but we want to keep that to a minimum. This is end grain, this is side grain. So anything at an angle is end grain. Now, if I was taking this down to the round as a professional turner and just simply wanting to get it into a cylinder, I will stand at the end of the cut, depending on how long the piece is, and I'll work from the tailstock side back to the headstock. So let's do that first. So standing in a nice comfortable position, ensuring I'm going to use the bevel. The bevel is the part that came off the grinder. We want that to interact with the wood. In other words, we're resting the tool on the tool rest, supporting with our right hand and using the bevel as a guide for the tool. So starting off the end, I'm going to grip the tool from underneath, not on top, because that pushes my elbow out and puts my shoulder under tension, and every chip would hit my hand. Now, I don't need a lot of leverage here because there's not a lot of overhang from the lathe, so I'm just going to keep my hand in a very comfortable position. Now, this is my comfortable end position, so I work back to a comfortable position when I can. And starting low, I'm not going to rub the bevel per se. This is rubbing, it's putting too much pressure on it. I'm going to float it in and push the tool at the same time. That way I'm going away from this wall of end grain to here, going away from it. Now once I've got a certain length done, I can go back and forth on the straight here, but always down the hill. Back and forth on the straight, down the hill, and I'm finding the bevel. Nobody is good enough to guess where it is. So I start, pull it in, there's a cut, then I lift only as the diameter gets smaller and traverse. Going back. Now at this stage here, I can start working this back and forth in short, light cuts, not big volume, because if I take big volume, here, you'll see it pull the tool in. That's because it's interacting with the end grain here. So light, short volumes over the top, or large, big volumes if I'm going off the end. Now let's make the piece parallel. So just using the tool rest if I can as a guide, that's not always possible, but I'm traversing from side to side. My feet position are parallel to the lathe, and that last cut I just cut a little bit slower, reduce the tool marks, and that is down to the round. Now my feet position were parallel the whole time. I kept the tool against my body because it's a straight cut to stabilize it. And that's a rough down cut there, producing just a side grain revealed surface there. Now if I want a finer finish, I could plane it, or I could simply cut slower. For myself, I'm not a big fan of planing the piece of wood because it's unnecessary, and if you use a skew, you've got to raise the tool rest, bring the tool rest in a little closer, and what have you. And with a skew, you've got to work off both sides. To get a finer finish here, I'll simply take my speed up a little faster now that it's smaller in diameter. So I'll get up to about 1800, and I'll just cut slower. Just a slow, methodical cut. Didn't have to change the tool or the tool rest height. And this will give me a finish that would be sandable. Let's say something like a rolling pin and what have you. So you can go back and forth here, make sure it's nice and parallel. And that gives us a very fine finish. And what we're always looking at on the surface is a continuous spiral from the gouge, because it's cutting from one side to the other. It's a continuous spiral from one side to the other. If you cut slow enough, then that spiral becomes very hard to see. And this piece of wood is now ready for... Here I'm going to use my 4040 bull gouge grind to prepare this block ready to go into a chuck. So this particular grind is an elliptical fluted bull gouge, but it could be a V fluted bull gouge too. It has a relief heel or secondary angle behind the bevel to keep it short. It has a 40-degree nose and a 40-degree wing, giving us an included angle of the wing plus the bevel at 80 degrees. That's important to be lower than 90 so we can get into a corner. Now this is an end grain revealing tool and a side grain removing tool, but it is not generally a side grain finishing tool. It will not give us as good a finish on side grain as it does on end grain. It's a specialist tool. It is the opposite end of the spectrum to this particular gouge, which is a side grain revealing tool that doesn't want to interact with end grain in any way. Now when we cut to reveal end grain, we don't actually cut the end grain. We still cut into the side grain here to slice through it. So we're slicing through the tubes, revealing the end grain, but we can take a large volume with this particular tool. Having a straight wing set back just 10 degrees from 90, it allows us to get a nice peel and into a corner and to produce a tenon or just a finished surface on the top of a box. So for now I'm going to prep this particular blank so I can throw it into a chuck and do some cuts showing the other types of cuts that can be done with a 4040 gouge on a spindle blank before we move on to a ball blank. We'll swap out the handle here, so we have a modular system here, and I'm simply going to use my 4040 in the same tool handle, which is a 20-inch one, and from here we're going to cut in perpendicular or 90 degrees to the lathe here just to clean up the end because it's a bandsawn finish here. Obviously not going all the way down because we don't want to hit the live center, but close enough that we don't have anything left in the middle. It won't go down the center of the chuck. So here, for this particular cut, I put my left leg forwards, my thumb on the tool rest, and I pinch the tool. I place it against my body, and I come in with the flute closed. So my nose is center to center. Center width of the lathe to center here. I start the cut in. Once I'm in, I slide my left hand back, open the flute, and I lean forwards on my left leg. When I get to the bottom, I just simply tuck it in. Now that's giving us a cleaned up face, but it doesn't give us a tenon. So for the 10 here, I'm actually going to go around just a couple more degrees. So I'm actually slightly undercut here. So going long enough for a good tenon here, almost about a 3/8 of an inch tenon. Bring in and give that a tighten. Possibly could have done with a little bit more tension on the tailstock there. That's where we got the vibration. So we'll clean up the end and do that one more time. So we'll clean up the end. Yep, tailstock was not fully tightened, and we'll go one more time in there to eliminate any vibration. And I'm also making sure that my shoulder here is slightly undercut. My tenon has got a little dovetail on it, and what we're able to do here is grip this on a dovetail chuck, and we can do some other cuts on the opposite end when we flip it over later. My background is spindle turning. So, needing to cut pummels, which is going from the square down to the round, I used a skew chisel as an apprentice with my father. The downside with the skew chisel is it's a small volume tool. It's a pure slicing tool when it's vertical. It can be used as a wide parting tool when laid flat, but it can't do both at the same time. And what I mean by that is, if it's vertical, it's taking small volumes, exposing end grain and slicing. If it's flat, it be used as a wide parting tool, peeling side grain. The advantage with the 40-40 gouge is it does both at the same time. It slices with the 40-degree nose, which is also pointy like the skew, but it has this wide wing that is straight. So it's able to remove tremendous amount of volume and allow the end grain to be really clean cut whilst it removes large volumes of side grain. So let's do a comparison between the two, and then we can realize where the 40-40 gouge came from and then why I started to use it for bowl turning rather than the traditional grind that my dad used to use. So, back to being a spindle block, our tool rest is parallel to the lathe, set at the correct height, not too far away. I'm going to run this about 1800 RPM. Now, I'm going to use the nose of the skew chisel here to slice through the side grain to expose end grain at an angle, usually about 40 degrees for a pummel, which means when I use my bowl gouge, it's actually perpendicular to the lathe, but it will be a different angle. It'll be 20 degrees to give us the exact same. So we'd have to set this tool back 20 degrees to allow us to get 40 degrees with the skew. Now, it only can use the nose, so we've got to be careful that we don't over lean this tool, because then we would catch the large wide edge into end grain and that'll cause it to pull into the work. We also can't have it vertical because then it's not slicing. So we've got to find that happy medium with the skew, so it's more sensitive than the gouge. But let's see how many cuts it takes to get this down to the round. So putting my left leg forwards and coming in here and seeing how many slicing cuts. About a 16th at a time usually. So we'll get set to the 20 degrees. There's one cut, two cuts, three so far, 4, 5, and probably 6 cuts might get us down to the round. Nope, it's going to take 7. 7 cuts to get the skew to cut the pummel. And although it's given us very clean end grain here, what we do have is the problem is that we don't have, although it gives us very clean end grain, the problem we have here is that we, oh no, I'm going to do one more cut. Like that, okay. In fact, we're going to end up doing 8 cuts here to clean that up. So in the end, to get that very clean, I had to do 8. So although it has given us very clean end grain here, it took 8 cuts. And let's compare that versus the bowl gouge with the 40-40 grind to see how many cuts it takes to get this to the same position. So let's start by going in square with the nose of the bowl gouge. So we're starting from the same position. So we'll clean this up. One more time. So in the same position. Let's see how many cuts it takes with the bowl gouge. So, depending on the width of the gouge, or the size of the gouge, that distance from here to here, that's the volume we can take. So, let's go for that now. So there's one cut, and that would actually almost get us there. We'll do a second. And a lot more effective to give us that exact pummel. And not so critical on actual opening of the flute. As long as we're reasonably open, we've got a wide margin of error, and like the skew, we can cut right in with a very clean pummel here. And then this would be finished off with a spindle roughing gouge. So we'll swap the gouge out, and let's use this spindle roughing gouge. Now the spindle roughing gouge is the ideal tool for exposing side grain. The skew is the ideal tool for exposing end grain. And so is the 40-40 gouge, ideal for exposing end grain. It's not a side grain finishing tool. This is a side grain finishing tool. So let's clean that area up and show you how we would finish a pummel. Now that's why spindle roughing gouges have corners. They allow us to get into a corner without damaging the other surface. Obviously you've got to be careful here that you don't go too deep because you will damage your pummel. So just right into the corner. That just shows you it finished off there. So we've got a surface finished by a spindle roughing gouge for side grain exposure, and a surface finished by the 40/40 bowl gouge for end grain exposure. So this is a standard pummel that we would use in spindle turning, but obviously this gouge can produce any shape of pummel. So I'll show you the other shapes and show why learning to do pummels, which is a spindle turning technique, can really help you with your bowl turning. Especially if we're doing bowl turning where we've got a broken surface. That would be natural edge bowls or burls, etc. Where the surface isn't continuously round, so we're going into a broken surface. Now something I'd like to mention about a broken surface is it's really important that we don't actually touch the tool rest with our lead hand. Now obviously our hand that's controlling the tool is the right hand here because it's got the handle, which gives us the lift, the push, the twist, the swing option. Our left hand is just a positioning tool and a weight. In my style of push cut, we don't use the left at all to control the tool. It's simply a weight. The right does all of the controlling factors. So we saw the angled cut there. Now notice as I was doing the angled cut here, if we go and look at it in a little bit more detail, and this would be the same on natural edge bowl, I'll simply not touch the tool rest and I'll be moving before I get to the surface and then continuing. Now, where this tool is really sensitive to pressure is if we put any pressure on the bevel. In other words, we rub the bevel instead of glide it, it will bounce on that surface. You can hear it bouncing there. So it's really important that we don't pull onto that surface. We line the bevel up and we glide on the bevel. Now, one of the other reasons we don't want to touch the tool rest with a hand is if we're touching the tool rest here and we start, we'll start off by bouncing because we interrupted the tool's path, which is going sideways on the tool rest here. So we must allow the tool to slide on the tool rest, glide on the bevel, allowing it to do an angled pummel. If I'm going in square, I'll turn the chisel and go in square. Now, there's enough solid material here that it might want to skid. Let's just see if it does. You see it might want to skid. Yes, there's one to skid. So this is one of the times where I'll use my thumb initially, get it stable, and then go. But out here, there is not enough solid material for the tool to pull sideways. The reason the tool is pulling sideways is trying to thread chase. So here there isn't enough solid material and I can do in a nice square cut. And then we tuck the nose and gouge in. So you can see the gouge is able to cut its full width of wing, giving a side grain peel away whilst it cuts the end grain. And you can see here I've slightly undercut. So if I wanted that perfectly square, I need to adjust my tool and go in a couple more degrees round and get it perfectly square. Now obviously in bowl turning we would use other shapes. This would be similar to the cut on the inside of a bowl. And there we squared it up. Now, you can obviously do convex, concave, OG, these are other cuts, so let's just do them right now. So convex is, again, not touching the tool rest because I'm starting on a broken surface here. I don't want to interrupt the cut. I can just let the gouge swing around to do a long convex cut. This would be good for practicing to allow you to do natural edge bowls where we do entry cuts on the outside of the bowl. And here you can see it's just a long domed cut here. And again, we're not getting any breakout or torn grain here. We can make it longer still, so we can come further back and do a longer cut. And this is great practice for any natural edge or broken surface. So here on this particular one, you can see it's a very long cut, super clean. Let's go to concave. So this would be similar to doing the outside of a bowl and here to the inside. So we're going concave. So again, but here for the curve cuts, no body contact on this, coming in, and we're going to swing around the other way. And that would be a concave cut. We're ignoring the side grain at this stage. But you can see we're able to get these really clean, super clean edges, super great finish on the end grain, because this we wouldn't sand on a balustrade, and on a natural edge bowl the least amount of sanding we do, the sharper we keep those edges later. And then there's just one other cut left, which is an OG. So an OG is concave to convex. So it's very traditional style cut in balustrade turning. Not my favorite because it's really hard to make two of them look the same. So you go in concave and then the convex. But making two of these guys look the same was really difficult. And that's an old style OG you'd see on an old post or balustrade from Victorian times. but making two of these look identical is really difficult. So I'd rather do a straight in or angled pummel. But this is showing you how learning to use a 40-40 on a square block of wood like this will help you with your bowl turning down the road or platter turning or anything where you've got a broken surface. I'm going to mount the block up I prepared before with the tenon on that was cut with a 40-40 gouge. Going to use dovetail jaws, making sure I clean the back of the chuck so there's no chips on it, that way I get true location. And before I go all the way up, I just give it a little bit of a spin, and then we can locate this into the chuck. Now, very important is that my shoulder is slightly undercut so that I get location against the front of the jaws all the way around. I've got a tail stock handy, so let's bring that up and use that to get the final location. And then we can tighten this up. Remembering that wood compresses over a period of time, so even though I can get this very tight now, in about 10-15 minutes time, that will have relaxed a little bit and it'll have a little bit of flex in it. So remember to retighten if the piece of wood is going to take you a little bit longer than 10 or 15 minutes to turn. So from here I can remove the tailstock out the way. Now with this particular block, I'm going to be talking about cutting and exposing end grain. Now, we don't actually ever cut the end grain itself, because if we do, that'll become a cat, because any uphill edge into end grain will enable the tool to be drawn in and pull it out of our hand. So we don't want that effect. So here I'm going to be talking about cleaning up the end grain. End grain is okay. Here I'm going to be demonstrating how to cut clean end grain. Let's try that again. Come on, you can do this. Here I'm going to be talking about cutting clean wide parting tool. Unfortunately, with the angle it's not ideal, so if you're going in at this particular angle, you're not getting a really great peel with the chisel because it's back 20 degrees. The 40-40 gouge is back only 10 degrees from 90 degrees. So with this particular chisel here, I could remove a lot of material by peeling and then fix it by slicing, but that's two different cuts to get one result. We could also use a beading and parting tool. And this tool is ideal for parting in because it's square across, so it engages directly with the side grain. But unfortunately, when it peels in, it does not leave us a good surface here. You could use this particular chisel to clean up the end grain, but it's not ideal with this long concave bevel, and it doesn't have a 20-degree relief angle on there, so as it's slicing in, it's a little trickier to use than the Skew for cleaning up end grain. You've got the option also of a spindle gouge. This is a great slicing tool. Unfortunately, it doesn't have a very deep flute, and a detailed gouge has less, and so its depth of cut is very limited. Plus also, with its wings being back an extra 10 degrees from what the bull gouge is, the wings are back to about 30 degrees, it doesn't give us great interaction with the side grain cutting as it's going in when you're taking volume. However, the wings need to be back on a spindle gouge for detail and to allow us to get a nice slice into very tight spaces. That's where this gouge is superior to the bull gouge with a 40-40. This one has an included angle of wing plus bevel of 80 degrees, but it doesn't get into less than an 80-degree corner. So let's try out these various chisels and see the difference between the two, and then realize why in this particular case the 40-40 on a bull gouge with either an elliptical or V-flute is ideal for cleaning up end grain and can be used in spindle turning. So before we use the bull gouge and the spindle gouge, let's use the chisels. So let's look at a chisel. This one is the beading and parting tool of the British. use a lot for spindle turning, and I grew up using this particular chisel. I rolled beads with this, not with a skew. I always rolled beads with this because rolling a bead I can go one way then the other way without flipping or moving the chisel, and it's got a 40-degree included angle which allowed it to get tight into the corners of the beads, so it's excellent for that. It's also excellent as a wide parting tool. However, being just a parting tool, when we part across the surface here, it will remove a lot of material, but it will damage the end grain because there's no slicing action. So let's see that in action. So just parting in here, straight in, taking about 3/8 of an inch. It's a rapid cut, very fast. But let's stop and see what the end result is. So parting in there, we've ended up with a seriously torn grain. And that torn grain is very deep, possibly up to a 1/16. And so therefore, will our skew clear it? If we cut it once, it might need twice. So what we got here was a pure peel with no slice. Let's go to a pure slice. So the skew chisel is a pure slicing tool when vertical. Now, keep in mind that skew chisels, we can only use the extreme tip. So we don't want any of this edge to interact with the end grain. So if we keep it vertical into here, that will pull the chisel in. Any edge pointing uphill into end grain is a catch. So from here, we need to set the bevel in, coming in square to the work, and a slight lean so we don't end up interacting with the end grain. And this is the slicing action. So from here, how many cuts will it take to clean this up? We'll find out in a second. So getting going here. Now the ash is a little bit chippy, you can feel it on, so you got to cut slow because it tends to chip. You can hear chipping there a little bit. It's not chipping the wood surface, but it just doesn't soft clear. Not a lot of clearance for the wood there with the skew. But that's cleaned it off, but it took 2 cuts to do so. In fact, it didn't get below all the torn grain, so we'll do it one more time. So one more time to get below the torn grain, taking off another 1/16 here. So although the skew chisel does a great job of cleaning up the end grain, it requires a little more skill than a gouge, and also the amount of volume you can remove is limited. So although it's cleaned up here, and you can see a little bit of bruising off the heel of the bevel on this because it has a fairly long bevel. So the bevel on this particular chisel is 3/8 and it's hollow. Now if you honed this flat, then you would get a better cut. How we achieve that with a gouge is that the gouge has a short bevel. This is something I introduced when I was in my mid-teens. Being a production spindle turner, I was the first to remove the heel of the bevel on all of our gouges because I found that it interrupted the cut, because we're cutting a straight surface or we're cutting concave, and that heel of the bevel being a curvature from the convex shape of the grinder, it marks the surface. So that's why I have a bevel that's always 1/8 or less on the nose here on the spindle gouge, and the same on my bull gouge, 1/8 or less. So let's use the spindle gouge first and see what we get. Now it is an effective tool at doing this particular cut, but it has a limit on volume. If we take a small volume, it's exceptionally good. Yeah, because now it's in slice mode only, it's not doing a lot of peeling, and it does a better job even than the skew, especially because of the short bevel, and we can slice through, and there's no concern about getting a catch because we have a lot of forgiveness in the orientation of the tool. So it does a great job. However, if we take a large volume, if we ask the tool to cut its maximum volume, which is from the tip to the edge of the wing, it is not so good at cutting here because we end up with this wing being so far back, because this gouge needs to be more pointy than a bull gouge, that it doesn't clean the side grain away as comfortably. So it kind of stalls on the cut of it. So let's take its maximum here. There it is. And you can hear a lot more resistance, powder coming off. It's not a nice chip. It's working very hard. It's struggling, and I'm working hard to get it. So it's great on these small volumes like this. Oops, get the entry cut correct. Great on small volumes, but on the large volumes, it is not liking it. So let's change it out for the bull gouge. So the bull gouge has got a 40-degree bevel, the same as all the other 3 chisels. But let's take its maximum width, which is from the nose to here. Now, you notice the gouge skidded on me before when I was entering. Let's make sure we lock it in with our thumb and pinch with the fingers. Get location. Once it's in the cut, we can move on that back. We can open the flute. And then you can see the massive volume, and these are a big, clean chip. Now, as you get to the center, slow down, slow down. It's a large volume. You don't want to snap that last bit off, so you want to take your time through to the middle. And that gave us a 3/8, well actually more than 3/8, half an inch cut directly to a surface that's sandable. So that's the advantage of this particular chisel, is it is actually a combination of the Skew. It has a pointy nose like the Skew, and it has a 40-degree nose like the Skew. And then the nose, or not the nose, but the wing of the gouge is straight like our parting tool. So it's doing this double action, this peel with the wing, just like the peel with a parting tool, and a slice with the nose. And that allows us to take large volume. Now, we don't have to just be doing cuts that are going in straight. We can also do cuts at an angle. So if I'm going at an angle, I can use the same tool to remove a lot of material. So just starting low with the handle, lifting in, I can do these large volume cuts, almost the width of the whole wing. So about 5/8 to 1 pass. I can take these large volumes, and I'm getting a really good finish at the same time. Now remember to decelerate towards the center. Decelerate, decelerate. The reason we need to decelerate is the wood is going a lot slower in the center. And on this last cut, I'm going to go a little bit less volume because it's too much volume when you get down to the center, and it'll want to snap it off. So we want to take our time there. If we look there, we should have a clean end grain cut, removing a lot of volume at once. Now I can see the tool mark on here. That's a spiral mark from the gouge. That means I'm cutting a little bit too fast. So let's do it again. This time, let's speed the lathe up to 2000 RPM. And on a block like this, we could be comfortable even going up to 2100. So let's go up to 2100 and cut a little bit slower. So by going a little bit slower, I'll reduce my tool marks and would reduce the amount of sanding I need to do to remove tool marks. One thing I do in my style of wood turning is I don't ever sand out torn grain because I don't get torn grain with push cut. But I do get tool marks like everybody else. So at certain points I've got to limit those tool marks, and by limiting those tool marks I reduce my sanding time. So you can see here we've got a nice clean surface cut on this, ready for sanding. And that's the 2 straight cuts there. So we went in square, we went in angled, and then the only other 2 types of cut is convex and concave, and there's a 5th where we combine both together. So if I cut off the end here quickly, because it's long, we'll just slice that off. Let's turn this into a spherical cut, which is where we're going round the corner. For this particular cut, I don't have body contact with the handle, and I finish on center. So this particular cut requires the tool to start with a flute open, facing the ceiling. And because I'm going around the corner 90 degrees, the grain changes 90 degrees, I rotate the tool 90 degrees and end up with the nose going through the center. So here, I've got my right foot forward because this is a curved cut. So if I'm doing parallel cuts, here if I was planing this piece of wood with my gouge, I would have parallel feet because it's a parallel cut. If I'm cutting in square, I put my foot in square, and I cut in square, going in like so. If I'm cutting at an angle, I just move my foot at that angle, and I cut at an angle. If I'm doing any kind of curvature, I simply swap my feet and put my right foot forwards, and then it allows me to do convex, concave, or an OG cut. So this is convex, spherical cut, slowing down towards the center always, so that we don't damage the wood fibers because it's going at slower surface feet. We'll do one more to make that into a true spherical cut. So this is where using a bull gouge, which is able to slice and feel. Now if we stop halfway down, let's have a look at what we've got. We're using always the lower wing, not the upper wing. We're getting a very clean cut because the nose of the gouge is giving us a slice on this end grain. You can see that the side grain here, or partially end grain too, is all damaged from the wing. The wing on the 40/40 gouge does not ever give us a good finish. You can see in this particular case here, it's destroying this material. But it's not. This is not the finished surface. This is simply what we're getting rid of. So it's exceptional, giving us this slice on this surface and getting rid of the wood that's in the way. Around the corner, slowing down, all the cuts slow down towards the end, getting the timing right so I get it to slice through the middle, like so we don't damage that last little bit. And that's a convex cut. Concave is the opposite, going the other way, push the nose in, and we swing back. So concave, entry cut there, then releasing with my left, swing round. Now if I was to turn that into an OG, I would simply do the concave as is, and then reverse in the end. So concave, and then round to convex. And there are all the different cuts we can do with the 40/40 gouge, removing a lot of volume at the same time. and clean end grain all the way around on the OG cut. All good. How's it going, Tom? Whilst I'm here, I might as well show you end grain hollowing using the 4040. It's a very rapid way of getting rid of material inside, say, a box. There are limitations, of course, but let's show you that in action. So first of all, let's just clean off the face and just show you a little bit of how to get the inside out with the 4040. So we'll set the two-rest up parallel to the face, and very important to set the two-rest height. I call it center to center. The very center of the gouge must pass through the very center here. Now we can see a little bit of torn grain on this block here. That is not because of bad technique or what have you. I was cutting very fast, too fast, and you can see it lifted the grain. So something to keep in mind is when you're roughing down here, you're cutting fast and it lifted the grain. When I do a final cleanup cut here, I must remember the ash is quite sensitive to how fast I cut. So let's just cut a little bit slower across the center. Just cutting slow, keeping the flute closed, not too open for this particular cut. And then we'll end up with a really good finish. Slowing down towards the middle, always, because the middle is got slower surface feet per minute. And you can see that that's cleaned up the end grain so that we don't have any damage on there. Now to hollow out, there's a couple of little things you can do, but I'm going to do the quick version, which is just using the one chisel. I'm going to scoop in and out and backwards, you'll see. So from here, we'll leave a wall thickness, say for a rough out box, say about so thick. So from here, I'm going to place what I call onto the bevel, not live cutting. Live cutting, if I place live, it will skid like that, you can see, because it's pure end grain. We don't want to go into pure end grain, we don't have enough support. So we'll start on the bevel and then swing in and swing back. And then we're still cutting primarily side grain. So doing the same again, we'll swing in and swing back. And that hollows out a little bit. This is a good way of hollowing out a goblet, but this I want to be a square sided box. So cutting back the other way. So here, what I'm looking to do is to cut in, cutting sideways and cutting sideways. So it's the same technique, just going in from the other direction. And there's a limit to how deep we can go, but let's go a little bit deeper for now. Now in a moment, my bevel being 40 degrees, it'll have a limit to get into there. So I can use this corner here as what I call a false bevel. I can place my gouge substrate against it and use it to get my gouge cut started to get in, and then I can cut backwards again. And we keep going. There's a limit to how deep we can go. Now, that's got us a very rapidly hollowed out section of the box, and we could keep going. But for the sake of talking about how would I finish inside a box on end grain, I'll always finish it with negative rake. So this is a conventional scraper. Conventional scraper here is single angled. This is one I use for putting my dovetail into the top of a bowl. We'll show you that in a moment. And being a regular scraper is a single angle. Now some people say, oh, regular scraper, make it negative rake by pointing it downhill. Well, simply pointing it downhill is not enough. That does not make it negative rake. What makes something negative rake is a double angle. That is an angle on the top and on the bottom. That changes the burr surface to be on a different plane to the resting surface. See, the burr on this particular scraper here is parallel to the top and bottom. So as this interacts with the end grain, it will pull it rapidly into that and grab very severely. So this cannot be made into negative rake. Now how people make these type of chisels in negative rake is they angle them. That's how they make it negative rake, and they call it shear scraping. But shear scraping is a form of negative rake. But rather than dealing with all that angling, what have you, I'm simply going to use a chisel like this that has a burr. If it doesn't have a burr, it's not negative rake, it's just a dull chisel. So if I use this without a burr in here, it'll just tear up the fibers. Now, this is a square chisel. Now, we all know square pegs into round holes don't fit, so I have a round version of this. So round version works really good. It allows me to go down the side and across the face. I could also use my skew chisel, which has rounded edges. So this particular skew has rounded edges, so it will go down the side, but the angle at the end means I tend to dig in here, and then I have to level from the other side. So let's use a little square across round one and clean up the end grain here. So remember, it has a burr. Now negative rake scraping means that your chisel is going to lose its burr very quickly. Set the two rests at the correct height. Now this chisel doesn't need to point downhill like a regular scraper, but it doesn't want to point uphill either. So it wants to be flat to trailing downhill. So keeping in mind, if there is no burr, it isn't negative rake. So I'm just checking which side the burr is on. There, it's on the top side there. So let's keep it this way up. Now, I can use this chisel, the side of the chisel, to get me a parallel side. Bringing it in. So from here, starting nice and flat, just pushing in, I can go down here, cleaning up the side. And then when it gets to the bottom, it will not be aggressive like a conventional scraper. When it hits the bottom, it just interacts, but without an aggressive grab. So from here I can then clean up the face, and this is negative rake scraping inside a box. Now there's the dangerous part of negative rake on a box. Do not go past center. I momentarily went past center, and you see it will kick, but it will not kick otherwise. So here just getting right on center. Be careful, like I did, not to go past center. So as long as you don't go past center, nothing happens with this chisel. It is not aggressive. And quickly in there you can see we've cleaned that up. So we have a really clean end grain here and side grain, and that's a cleaned up square in box. And there's no limit to how deep you go other than leverage and the thickness of the bar. Here I'm going to get on with the bowl. I've got an ash blank. This is an olive ash, or it's what I call olive ash. It looks like olive wood with a dark heart here. And ash is what I turn for the spindle turning section as well. Now, I'm going to mount this between centers to then prep it to put it on a chuck. So what I'm looking to do here is put it onto a large drive center, not a mini or a small step center. And then all I'm going to do is prep the face. Then I'm going to put a recess into this section here. I'll put a recess into here, and then I can put it on a chuck. With push cut style of turning, which is the style that I've developed from the European push cut style, for bowl turning, is we need to remove the tailstock for both the outside and the inside. So we need to put it onto a chuck. I prefer to put it onto a chuck rather than a screw chuck or a faceplate. They also take a bit of time, require other tools. We've always got a chuck of some kind alive in the drive center, and with those three I can make this work. So first of all, what I'm looking to do is to mount this particular blank up onto the lathe. But let's talk about the tools we'll be using. We'll be using the 40/40 bowl gouge here. This particular one is a one-way one, and I'll also be using my own gouge, the SB one, later on, showing you the beam-shaped version that I have that's laminated. And then we'll be using a bottom bowl gouge. This is a Doug Thompson 3/4 bottom bowl gouge, based on the design I developed with Jerry Glazer some 25 years ago. Doug Thompson now makes a copy of that, and this is a very nice gouge as a bottom bowl gouge. So we'll mount this particular block up between centers. So what I do is I bring up my tailstock reasonably close. I'm going to put the center dot, which is already marked on the piece. I'm going to put that onto the tailstock side. Now, let's make sure that's clamped down. And what we'll do, we'll wind this in until we get location. Now, obviously, we don't want to be running something like this. We can see that that's not going to be suitable. So then we straighten it up till it looks reasonable. And once we know it looks reasonable, then we can tighten it all the way. So a little bit more. And that's not bad there. Okay, so now important that we get the teeth to bite in here, because if they don't bite in correctly with your 2-prong/4 prong, it'll start to drill a hole. And it's not that we're going to be aggressive or running fast at this stage, but I'm going to make sure it beds in well. So good tightening here, tighten that in, and I'll give this a little bit of a wiggle to get the teeth to bite. One more tighten, and just make sure everything's tightened out, and then lock that up. Now, I am not going to take this down to the round in this particular position, because I don't want to stand in front of it, because it's only between a point on the live center and a point and some prongs on the drive center. Now we are going to start slow with the speed, so the speed is way down. We're going to set up and work on the face, and therefore we don't stand in front of it at all. We set our tool rest to just below center. That's going to be enough height for us to allow us to flatten off the face and scoop out some of the material to allow us then to use a little scraper to do a dovetail. We're going to dovetail in here, dovetailing wide onto that. So at this stage here, we are set up, we are locked, locked, everything's locked, check it clears. Starting off slow. Now the maximum speed we ever want to run a blank like this at when we're between centers is 1,000 RPM, and obviously that needs to reduce as the blank gets larger. So 1,000 means that if it came off the lathe, something failed, something loosened, what have you, the blank, when it's below 1,000 RPM, always goes to the floor, and therefore we're not getting it thrown at us. However, we don't want it to come off, so we do need to keep the speed below 1,000. We want to be careful when we're preparing the block, but once we're on a chuck and we'll be using big jaws, then we'll be very secure. So checking our speed at this stage here, we'll take this up and see how we are for imbalance, because obviously it's not a perfectly round blank, and I'll explain why I'm not using a perfectly round blank in a little while. So here we're at 950, and that's good. Okay, so let's get this prepped up. So what I'm going to start off with is using my 40-40 gouge. Now it's excellent in flattening this off, but it will not leave me a good finish on this surface. But this is not truly a finished surface. It's just rapid to level the face, scoop out enough material to allow me to use my little 10-degree scraper. It's just a square scraper. It's not a negative rig scraper. It's a conventional scraper. It will need to point downhill. It's got a 10-degree angle on it to match the dovetails, and I'll be pushing it in there so that my jaws can expand and grip that very securely. So let's start by leveling the face. Now on leveling the face with this, what I'm looking to do is to use the wing of the gouge, which is straight, not the nose. The nose we want to protect. We don't want to wear or scrape on the nose. We'll be using that for finish cuts later. We're just using the wing to peel the surface here. I put my left leg underneath, my right hand on top, my left hand on top, should I say. Let's start that again. So here I'm going to prepare the surface on the face here with my 40-40 bowl gouge, and then I can scoop out enough material then to come in with my little scraper. My little scraper is just got a between 70 to 80 degree bevel angle, single angle, it's not negative rake. It has a burr on it because it's going into side grain. If I was going into end grain, I would never have a burr on a conventional scraper. It has a 10-degree angle on the nose, which allows me to dovetail in here and create a nice dovetail shape for my jaws to fit in there shortly afterwards. Now, when I'm using the 40-40 gouge, it's important that I use the wing of the gouge and not the nose to level this face. I'll use the nose to scoop out with, but not to level the face. It will not give me an excellent finish on this surface because this gouge is a side grain removing tool, an end grain finishing tool. It is not a side grain finishing tool, but it's going to be very rapid to level the face. Now remember, this is a bowl blank and a side grain bowl blank at that, which means I've taken a pencil grain, not spindle grain this way, I've taken a pencil grain and it's rotating in this format, which means the side grain is on the front. There is a little bit of side grain here, a little bit of side grain here, but the rest of this blank is all end grain. So therefore, when we start shaping this bowl, we're exposing end grain much more than we're exposing side grain. So this particular tool is an end grain exposing tool, but right now I need a rapid cleanup of the face to get it level, scoop some out, and then we can dovetail in there. So with our speed at 950 on this blank, I'm not standing directly in front of the piece. I'll put my hand on top here, and I'm going to use my handle down. So I'm actually using the bevel as contact to come in here and get a nice peel. Now, if there's crazy grain in here, some big knots, a crotch figure, then I would lift the handle and I would scrape it down to the round, and that's okay too. But if I have the advantage of getting a peel cut, I'll get a peel cut here. Now, I'm not pushing into the surface because it'll just become a jackhammer. I'm just floating on the surface. My left leg is underneath the cut, and I'm using body weight transfer between my left and my right leg to level off this surface all the way out. You can't really see the outside corner, so you need to travel out further than you think. Just the bare minimum there. Now, obviously, the size of jaws I'm using are around about 4 inches, so I'm going to guess that around here, and we'll scoop out at that. So scooping out once, and then flipping the tool to go in the other direction. And that gives me enough space to get my jaws in here. In fact, actually, I'm going to go with a larger size set of jaws and go a little bit wider. A little bit more wider. Now, obviously stopping before I get to the bottom, because this is now a wall of end grain. If I travel into that, it will grab. If I need to get rid of more of the middle, I rotate the tool on its axis and push it from the side. Now, that's enough space for my scraper here. So, just changing out the blade. Now, this is a scraper, conventional scraper. It must point downhill. It is not a negative rake. So, taking it high, this is a little bit awkward. Sometimes this knob gets a little bit in the way here. I'm just going to push into the corner and form a dovetail. So we want to go in a reasonable depth. So I'm going to go in at least 5/16 to 3/8 on this. And using the scraper here, not too aggressively. We don't want to make it too torn up in there. So we're just getting a nice surface in there for our jaws to locate on, and a 10-degree undercut. So a little chamfer on the corner here, and that's okay. And then I've got an undercut here and a flat surface for my jaws to locate on here. And if as you can see, there's a side grain finish. It is giving us a really appalling finish on this. There must be crazy grain in here, and the 4040 lifts it right up. If we wanted to clean that up, let's show it now. Let's grab a bottom bowl gouge and show how the bottom bowl gouge won't create that defect. So a bottom bowl gouge is a side grain exposing tool, not an end grain. It doesn't like end grain in any format whatsoever, but because of its duller angle being around 60 degrees on average, but sometimes down to 50 for a platter, but the more figured the wood, you want a higher angle like 60, 65, it'll cut through this without lifting it. Plus it has a tight radius, whereas the wing on this gouge was straight and wide. It's like a big, like a bit wide planer blade where the grain is crazy and just lift it up, so it's not doing us any favors there, the 4040, but this gouge will. So just showing you here in demonstration that we can cut across here and not lift the grain using a bottom bowl gouge. Now I won't need to take it all the way down to the bottom of the torn grain, but I'll let you see the difference between the two cuts. You see that this one is not lifting the grain. But at this stage, this is not a finished cut, so you can see it's getting below the torn grain there. One more time. So this is a side grain finishing tool, not an end grain exposing tool. So you can see the difference between the two types of cuts. So no torn grain at all there, it just cuts right through it. Okay, so you can see the damage from the 4040, but it's rapid. So this stage here, we'll flip this around and put it onto a chuck. So as you can see, it was just held in on a 4-prong drive center, but it was a large one. Don't use a mini one because we want to get a really secure grip on this. Okay, remember to clean the back of the chuck, make sure there's no chips on it for location. And then we can expand into there. Now, obviously, if you ended up with a really big noggin in the middle here, it's time to chisel that off because we don't want that to bottom out on the face of the jaws. We want location on the front of the jaws here, and then we'll expand into that. So there's our location, but let's take advantage of having the tailstock here right now and use that because it is better at locating than we are. So bring it up and ensure it's just pushing in a little bit. So we got true location, that's looking good. Then I can tighten this the whole way. So I'm expanding. Now expansion is very good when there's lots of wood, and there's lots of wood here. Expansion is not so good on the bottom of the bowl because there's less wood and it wants to burst out. But here we've got substantial amount of material, so we don't have that problem. So let's remove the tailstock, and in fact, let's leave the tailstock here. This is a safety factor. Because we're going to take it down to the round, and because I teach classes often where we end up with Nova chucks mixed in with Vic Mark chucks, mixed in with one-way chucks, students are used to a chuck rotating the certain way for them, and they will often tighten the chuck the wrong way because they're working on a chuck they're unfamiliar with. So I always recommend that we keep the tailstock here whilst we get it down to the round, because we're standing in front of a piece of wood. It's an octagon, not round, and if something to go wrong, the tailstock will 100% guarantee that it's not coming off the lathe. So we'll leave that in situ, but let's set up the tool rest as we require it, which is a parallel cut. I am not going to start shaping the mold immediately. I never start shaping the bowl immediately with my style. If you watch somebody like Mike Mahoney, he will start immediately shaping the bowl, but I want to get mine down to the round, get rid of the imbalance. So I'm going to get rid of the imbalance in 3 ways. I'm going to get it down the round here, from an octagon down to the round. I'm then going to level the face, which is also not flat yet, and then I'm going to cut off the corner, especially because this has got bark, so it's got some imbalance there. Then I will form my shape, because for push cut we want to be able to form the shape in a different way to pull cut. And so with push cut we want to have the piece reasonably uniform. There are some major advantages with that. And so the first thing is, let's get it down to the round. We set up our tool rest in the correct position. We check our height, we're just slightly below center, and we are able now to cut this down to the round using the 4040 gouge. So with the 40-40 gouge, the secret to using this gouge correctly is that we have the bevel. The bevel is going to track the tool. So we're going to guide the bevel and the bevel will guide the tool. So we want that bevel running parallel to the tool rest along this cut like so. Now the grip is essential. What I do here is I place my thumb in the flute. Now if your flute's worn down, you can place it on the substrate and I wrap around. These wrapped around fingers are critical to this. We want this wrap around so it's pulling down with both the thumb and the fingers. Thumb in the flute it works well as well, depending on how long your flute is, because as your gouge wears down, it may not fit anymore. We can even hold it back here. It's just this grip, and we want to have this little bit of a space in our hand here. We're not gripping like so, because this prevents us from being able to maneuver the tool any way we want. Our left hand is just adding weight and positioning the tool. It is not controlling. It is not pushing or pulling onto the bevel. We're going to glide on that bevel very lightly. By gliding on the bevel, I will not get beaten up from these corners. And this is why I give all my students octagon bowls, is because it allows them to practice taking it down to the round. If we start with round, they don't get the experience of dealing with pieces that are imbalanced. And if we cut this correctly, then there's no vibration that goes back through to our body. I will have my feet parallel, and I will stand at the end of the cut here, very comfortable. And then we can push from one side through to the other. So from here, got the thumb and the flute, fingers around, standing at the end of the cut, checking that the bevel is running parallel with the tool rest or parallel with the face of the blank. We can take different volumes, but we'll take a fairly light cut at this stage and just show you how it's exploding through the surface. So let's get halfway and stop and see what we've got. So we'll stop halfway. So you can see that we're peeling away the side grain, pure side grain, peeling away here, exposing end grain. This is exposed end grain. There's no torn grain here. It's cutting through really clean. And that's because we've got our handle down just enough to get a slice with the nose, the flute open just enough to get a peel. So if you look at it from the other side, so you can see in the camera there, we are going like this. Just open a little bit and down a little bit. Just down probably 10 degrees to 15 max. Flute open from 9 o'clock to about 10 o'clock. So let's do this cut again all the way through. So standing at the end of the cut, there's my grip. Feet parallel, I lean, and I slide, glide, float the bevel, not ride the bevel, it's just floating on the bevel. Look what happens if we ride the bevel. We take my fingers away, and we press in with the thumb. It's a pneumatic drill. It is bumping like crazy. So, gliding on the bevel, essential for this cut. Now as you get towards the end, slow down, because you don't want it to burst through. Nice, slow exit. And let's go one more cut. So now I'm going to go another 50 RPM, so I'm at 1200 RPM. And let's get this down to the round, and then we're ready to do the next cut. So gliding on the bevel, there's no vibration because I'm gliding on it. Then slowing down towards the end of the cut. And that's down to the round. Okay, now we don't care about the broken out surface here because we're going to shape the top. What we need to do now is to remove our tailstock because it's actually in the way. So we don't have torn grain and we've got a tiny bit of the flat left, which is fine. That'll come out when we shape it. Now from here, let's move the tool rest round to level the base of the bowl. So making sure that we got the bowl gouge at the correct height, just check the center to the center, which it goes through the center is correct. We can tighten that up. Now at this stage, I've not got any angle on the tool rest. It is parallel to the face of the bowl, remembering that this is side grain, just like a pencil. It's the side of the pencil is side grain, the end of the pencil is the end grain. So this is our end grain here, and our end grain here. But nearly all of this is end grain. There's only a tiny bit of side grain here and here, but all of this is side grain. So the more we cut into this face here, the more we're dealing with side grain, which is ideal for us. So we need to flatten this off and then cut off the corner. So 2 more straight cuts before I start doing a curved cut. So from here, I'm going to put my left leg underneath the cut, that way I can lean onto it, and then get this nice peel back and forth. Now don't pull into the surface, because again, we end up with this pneumatic drill, jackhammer effect. We just want to glide over the surface to level it. Now, you may want to leave that hole in the bowl for remounting later, so we'll leave that there. So when we've roughed, because we're going to make this into a rough turn bowl, because it's a wet bowl blank, and we can get that later. Now, what I'm going to do is I'm going to turn to the side, and cut off the end of the bowl, just the corner. So the bowl blank is being cut off the corner with my handle perpendicular, so I'm cutting still primarily side grain. And one more cut like that. Now I didn't move my tool rest for this cut. And the reason I didn't move my tool rest is, if I'd moved my tool rest immediately ready to start a curved cut, then I would have to move it again. At this stage I did 2 cuts here, and now I'm going to move it to position for curved cuts. Now when I say move it to position for curved cuts here, my handle is going to start way over here and it's going to swing to the top. So in this particular situation here, I can start my cut anywhere on the face I want and swing around. Obviously we want to start on the corner and work our way deeper and deeper into the cut. Now as I demonstrate this cut here, it's really important to understand what we're doing with the bevel. The bevel, this little guy that we took off the grinder, and remember we've got a shortened bevel, we have to relieve our bevel. Our bevel's only 1/8 of an inch long. And so we don't want to start with the bevel coming in too steep because that's going to reduce it down to the bowl. We want to start with the bevel pointing outward, so we're cutting the bottom of the bowl off first. We don't want the flute too open because that'll make the tool aggressive. As it swings around the corner, there is a percentage of end grain, and it'll want to pull the tool on its axis round. And we need leverage. So I have enough leverage, I believe, with this gouge handle. We will find out in a minute. If not, I'll put a longer one on. So we're going to swing around. So we don't want this grip like this on the handle. Or the blade, should I say. We just want this so we can pivot the tool. You want your left hand to be like a good dance partner. It just follows around the lead hand. It's just going around with us, giving us enough downward pressure. That's why we wrap our fingers around. Everybody I ever teach always releases those fingers, and then we end up pressing with the thumb, creating a bounce. And you can hear that. You can hear just by pressing on here. That thumping noise, thump, thump, thump. Cancel it. Thump, thump, thump. Cancel it. So we've got to keep that cancelling all the time. So let's try one of the cuts for now. Speed back up a little bit more again, back to 1200. Okay, starting with the cuts here. Let's cut outwards first. I'm cutting outwards towards the outer diameter with little limited swing. So coming in once, coming in twice. We'll power through that. So what we can see here is we've not reduced any of the diameter up here at all. We're just getting the base correct. Now at this stage my overhang is starting to get to be a little bit too long, so we'll stop the lathe while we reposition the tool rest for this. And not too much angle. So my tool rest is not at 45 degrees. That would not allow me to start my cut. It is about 20 degrees further around, compensating for the gouge having a 40-degree bevel on it. So the gouge does not cut along its length, it cuts at a 40-degree angle because it's got a 40-degree bevel. Now can we make it to the end there? Just about. So let's go for this cut again. So there's the grip. Downward press with the thumb. So the thumb is not underneath, not bridging, and not pushing in. It's pushing down and cancelled with the fingers. So watch what happens if I don't cancel with my fingers. You'll hear the bounce come in, and the bounce will get worse, it gets worse. You can hear that thumping noise. And that's the bevel bouncing on the surface, so we can clearly see. If we darken that up, you'll probably see a bounce mark on there. There it is. You can see the various bounce marks all the way around, where it's bouncing on the different hard and soft grains and end grain, creating these waves. So important that we use our fingers to cancel our thumb. Our thumb is pressing down, but it's not down enough. It has to be with the fingers as well. So there's the fingers cancelling the bounce. And I can slide it back further if we're going to get in the way of the tool rest. So that's only 3 cuts, and already I'm already close to the bowl shape. So that's why it doesn't take me long to get it down to the round, level it off, cut off the corner. Then we do 3 to 4 cuts, and we're basically ready to sharpen the tool and do our last cut around. So remember, look how far around I'm stretching around here. I've got my weight on my right leg. I'm transferring my weight gradually back to my left leg. The gouge handle is not touching my body. If it touches my body, I cannot reach far enough. So we want it to come to our bodies as we come around. And we slow down the cut here. And no need to go all the way out. We're ready for our final cut on this bowl. So what we've got here is superb, clean end grain here, no bounce marks. I'm not pulling the gouge around with my fingers. So really important not to use those fingers and pulling it around. That's scraping. If you pull it around, you will damage the nose of the gouge. And so what we do here, let's set for the final cut. And this is the time when to sharpen. Now, I'll be covering sharpening in more detail at the end of the video. So I'll sharpen this up now, and then I'll show you how I did that in a little while. Now it might seem that, hey, I do not have any torn grain, why would I sharpen the gouge? Well, here's the thing sometimes, is it looks like you have no torn grain, but your gouge is cut several miles of chips, it also cut through some bark, so if that edge is slightly dull, then it'll appear on your last grade of sandpaper or when you put your final finish on. So worth your time to sharpen the gouge on a CBN wheel. It costs you about 5 to 10 pennies to sharpen it, a lot cheaper than sandpaper, and therefore we know we're going to get the very best finish we can on this outer edge. So there's the end of my cut. So what I do here, stand at the very end, take my left leg back, my right leg forward, get the grip. I'm going to give that a tiny bit more angle. There we go. And I'm going to enclose the bowl, so I go slightly downhill. So picking up on the cut here, off we go. Now cutting slower because it's a finish cut. So slower cut, nice controlled, fingers cancelling the thumb. Volume doesn't matter for push cut. It doesn't care if you take a quarter or half an inch. It just doesn't care. It's because the nose is giving the finish. The wing just removes more bulk if you need it to. And just slow, continuous curve all the way through. Now remember to slow down here, go down. I'm technically going downhill the wrong way here. I'm going very slow. At the end of this cut here, what I'm looking to do is just to put a tenon on right here to fit in those jaws. So the base of my bowl is about 1/3 to 40% of the original bowl. So here, I'm just going to cut in and just form a dovetail. I tend to have the corner missing off my tenon. And later on, when I do finally shape this bowl, I'll do an OG cut here and bring it back down to round. But this bowl is now complete on the inside, on the outside, ready to complete the inside. So you can see we have absolutely no torn grain here, no bounce marks, and the tool marks are to the absolute minimum, and this blank is ready for reversing and then hollowing out. So taking our bowl blank here, we're going to reverse it round. The jaws that I used on the inside should fit for the outside on this particular bowl. This is a Vic Mark chuck, for those that want to know, and I'm using 4-inch jaws on this, or I believe they call them 100mm jaws. And whilst I've got a tailstock here, let's take advantage of that. The tailstock is much better at giving us location than we are holding it there. I'm looking down and making sure that I have no gap between my jaws and the shoulder of the bowl blank. And now we can tighten this securely. Make sure it's running true, which it is, and give that all the way. Now remember, if you're going to take quite a bit of time to turn the actual inside of the bowl, or you do it in 2 stages, whatever, is that this will need retightening at some stage. So for now, we're going to turn this as if it's a rough out bowl, which means we're going to leave it 10% diameter, and then we'll take it from there. Now I'm going to use the 40/40 gouge here. This is a one-way gouge. It's made of M4. It's a great gouge. Not perfect, but pretty good. It's got an elliptical flute on this. I haven't sharpened it since I've done the outside of the bowl, but I will sharpen it for the last cut. But the most important thing about hollowing out the inside of the bowl is that we want to be cutting in straightwards. The straighter in we cut, the less we deal with end grain. If we're swinging towards or cutting towards end grain at any stage, we're working much harder than we want to. So checking the tool rest height is correct. What we're looking to do is to level off the face here and here to get those down. Now remembering that this gouge is not particularly good at giving us a finish on side grain. So from here, keep the cuts to low volume, just so we're not doing too much lifting of the grain. And then pushing this out the way. So I'm going into the side grain. So my cuts are going directly in. If I go in this direction, you hear the difference in the cut. That is end grain. You hear the rumbling, and it's wanting to grab. So there's no reason to want to cut into the center. We want to cut sideways, getting these side grain chips. Side grain. Now what we've done here is just like on the outside of the bowl, we've leveled 2 surfaces. We've got rid of this waste and leveled it. We've leveled this surface. Now we can cut in. Now to cut in, we can't cut in with the bevel at 90 degrees initially because there's nowhere for it to go. If we cut straight in with the bevel at 90, which is to match the outside shape of our bowl, then we're going to have problems. So what we're looking to do is form a V cut. Now this cut here, have to be cautious on this cut because we want the flute open about 45 degrees. We do not want it closed for this cut. This is not an entry cut where we're entering on a rim with the flute completely closed. We want to start with the handle perpendicular. The tool must be at the correct height, so it must be able to get the center without lifting or dropping the handle. We place our thumb on the tool rest and pinch it. Once the nose is in, it is secure because there's wood behind the bevel. I can then slide my hand back and push to the middle and get rid of that center core. We do that a number of times to allow us to get into position for our entry cut in a minute. So again, thumb on the tool rest, fingers pinched, it's stable, slide them back, push in. Why are we sliding our left hand back? To be safe. If we keep our left hand here all the time and somebody goes past center by mistake, being tired, pushing too hard, and it flips the tool, it'll flip it on top of your fingers. So we want it away from the front for this cut. We do this enough times to get a little bit of depth. Obviously there's the option of doing this with drilling a hole and doing it that way with a drill bit, but I don't want to pick up another tool. I am just cutting in straight, no swing at all. If I start swinging, I'm swinging towards end grain too early. I am just making space. Now at this stage I can feel it, this handle is going to be a little bit short because my overhang will be greater on the inside and the outside, so I'm going to change this for a 24-inch handle. So just changing out my 20, putting on a 24, leverage is king when it comes to bowl turning. And nothing wrong with going even longer. These handles go up to 42, so if you want 42, use 42, but that would be overkill. So here's where we're going in. We're going to take our bevel in at 90 degrees to the cut. So I need my bevel to match this angle. So my bowl's about 90 degrees entry cut. I want my bevel to match that angle. It's going to go into the work with the flute closed. I'm going to use my thumb on the tool rest, not on top of the tool. If I leave my thumb on top of the tool, it can still skid. It needs to be here and then here. Now I can't start at the top here. That's going to end up being too deep a cut. So I'm going to start part of the way down. And it does want to skid there too. So place it in. Now it's stable. Remove. And I only swing enough to be cutting side grain. I do not swing all the way to the center. So I'm just doing a series of straight cuts, and these grooves in here will become my friends. I can use them again later to reposition my gouge, because my gouge entering on a flat surface wants to skid, or entering on a taper wants to skid. So if we just demonstrate that and how the gouge wants to skid on this surface, if I place the gouge at an angle straight onto this, you'll see it will simply skid because it has no location. So that's why we need to use our thumb as location temporarily. We're basically making a false bevel. We're making a bevel there, support, until our bevel has got some wood behind it. Once it's got some wood behind it, it's stable. So from here, we can keep cutting in. And what I'm doing here is I'm practicing my outside shape. I am practicing this section of shape of my gouge at this stage. So I'm just practicing it going in. I can take as much volume as my gouge will allow, and also depending on horsepower. So keeping in mind this is a 3 horsepower lathe, so I'm not likely to slow this one down, but if you've got 2 horsepower you may have to go a little slower. So there's location, slide back, and off we go. Taking about 5/8 in one pass. I'm getting to practice my outside shape. And here as I come around the corner, as I get around that final corner, this is starting to turn into end grain. So as I'm turning into end grain, it's essential that you do not run all the way into it with the flute open. You must close the flute towards the end. So the gouge starts with the flute closed, open to throw the chip, goes around, and then closes at the end so we don't run into that end grain. Now deciding on the wall thickness, let's make it about 10%, about there. Let's keep going on that. So pushing in and swinging. Now, how am I positioning my left? I'm actually placing my thumb behind the center of the tool and my fingers not in front on this cut. If I place them in front, they'll create a bounce. Really important that we don't jam the tool onto the surface. We can hear that if I push in there and I use my fingers, it will create a tremendous bounce. Remembering that this is a mixture of end grain and side grain. So if we're rubbing on this surface, we're creating friction and we're bouncing off the side and end grain and creating that imbalance. So really important, the left hand position here on the inside like the outside is getting the correct position. So thumb behind the tool as I enter, and I slide it below, my fingers below the cut, and then round the corner I can go. Using leverage with a 24-inch handle, getting towards the end grain, close the flute. Doing the next cut, one more. Going around the corner, there's the end grain, closing the flute. Now I've got one more cut to go. Now, this being a rough out bowl, would I sharpen the gouge? Probably not for a rough out bowl, but we can take this bowl a little bit further and see where we got to. For this bowl here, would I sharpen the gouge for the last cut here as a rough out? Probably not. But let's do the last cut here. Now, what's important? How far do we swing this handle? We always swing a 40-40 gouge to the point where it almost touches the rim of the bowl, because that way we know that what's left at the bottom of the bowl is suitable for the bottom bowl gouge. If we don't swing it to its max and we bail out early, the bottom bowl gouge will not like to cut this area. There's too much end grain here. The bottom bowl gouge likes the bottom of the bowl. It does not like the side of the bowl. Remembering that this is all end grain. This is an end grain exposing tool, not a side grain exposing tool. So this doesn't like the side grain. You can see what it does to the side grain. It destroys it, but it loves the end grain because it's a slicing tool with a peeling action. So let's do the last cut here. I'm not going to sharpen at this stage for this. There's the entry. Slide back, fingers not in front, but from behind the cut. I'm swinging round, slowing the cut down, getting to the max swing, almost hitting the rim of the bowl, closing the flute, and we are done there. So that's the inside of the bowl roughed out. No torn grain, and if there was a little bit of torn grain here, that would indicate that my gouge is dull. So the grain isn't perfect. So could it do with sharpening? For sure, it could do with sharpening. If I was looking to finish a bowl right now, the finish would be a lot better. In fact, let's just give it a quick sharpen and see the result. Because here I can see that the grain, it's not particularly torn, but it's a little bit rough to texture. So would that be sandable? Probably not. If you try to sand that even with 120, 150 grit, you're going to be left with some trace marks, because cutting out the middle of that bowl took about, let's say it took 2 minutes. That's over a mile of chips that you relied the nose of the gouge to give you a slice all of that time. So it does dull in that time. So here we'll just do a quick cut to see the difference between a sharp tool and a dull tool on the same piece of wood. Now this wood isn't soaking wet, it's been cut a number of months, but it isn't dry. So if you were to try and make a finished bowl out of this, it would definitely warp on you. So keeping that in mind. But let's just see the difference in the finish from here. So making sure that we've got the nose going in, entering there, not taking a big bite, and just sliding on the bevel, just taking a light cut. Let's see the difference in the two finishes. So if we stop part the way down, the difference in the finish between this area and here is quite dramatic. And even though this is quite an exotic steel, it's powdered metal M4, it's still dulled in the time it took to cut the inside here. So from here, let's just finish that cut off all the way around, and then we go to the bottom bowl gouge. Slowing the cut down, remember there's end grain when you go around the corner, close the flute, and we're good. Now, I've left enough material here to demonstrate the bottom bowl gouge in action and some of the problems that people have with it. Would I leave this amount of material normally for the bottom bowl gouge? No, I would remove more with a 40-40 normally, but the bottom bowl gouge is one that's tricky to use for a couple of reasons. So let's move on to the bottom bowl gouge and talk about. So we're going to move on to using the bottom bowl gouge. This is Doug Thompson's version of the Jerry Glazer gouge that I had made over 25 years ago. Jerry Glazer is no longer with us. He was a great pioneer. He's the gentleman that brought in powdered metals to wood turning, high wear resistant steels. This is my original shape one. This one is a tipped gouge, has an aluminum handle with lead shot in it. Not suitable to use in the UK because aluminum handles get too cold and we don't heat our workshops as much, so it gets really cold to hold. That's why I went to composite and a lobed handle. This is a lobed handle, but it's aluminum and it has to have lead shot in it, otherwise it vibrates. So aluminum by itself vibrates, composite does not. You can see they're almost identical gouges. And so this is my original bottom bowl gouge, as I said, with a 15V gouge in it. This is a 10V Doug Thompson solid bar, and using a 24-inch handle, that should be enough leverage on this. We need to make sure we have a 5-to-1 ratio. So whatever ratio I have here, I must have 5 times me behind the tool rest to now allow control. Anything less than the tool will want to lift in the handle for us. So keep that in mind. Now, we can use this guy to level up this face here, but one thing that's important, this gouge is 3/4, not 5/8. My last gouge was 5/8, so I need to drop it down for that and add a little bit more drop as well to keep some upward angle and about a 10-degree angle in. No more than that. I do not use curved tool rests. I would much rather use leverage than a curved tool rest, because curved tool rests are always curved too much, and by the time you get to the middle, you hit the end of the curve. So let's stick with the regular tool rest in 10 degrees there. And from here, now, the secret to this gouge is, this last gouge that I used, when I finished the cut, I was still near the lathe. I'm not too far away from the lathe, but this gouge here will require much more distance from the lathe. So the end of the cut will be, because it's got a 60-degree bevel on it, will be 30 degrees from the center of the lathe. So if I don't stand far enough back, then I'll be blocking the tool's path. And if I block the tool's path, then the bevel will come off the cut and it will start kicking. So we need to use the bevel. So we don't want to start live. Live is just sticking it in there and it's grabbing. We want to find the cut and get going. Find the cut and get going. So what I'm doing with my left hand here is gripping because it kicks initially, then releasing. My left hand is staying on top of the tool, not behind it, not blocking it with my thumb. I am not preventing it from sliding backwards, and I am not using my left hand as a fulcrum. I am simply using, taking up to 1250 there, simply using my palm to weight the tool, not to control the tool. I'm not using it as a lever. And you can see how nicely this peels the side grain. Because it's side grain in front of us now, we're peeling the side grain. Again, my left leg is forward so I can reach into the lathe. Now, let's show you what happens if I stand too close to the lathe. The handle will hit my body here, and I will not be able to swing it any further, which means I have to push it to the center. And you can hear it jumping and kicking and making these ridges. That means the bevel is off. If I leave my thumb behind, I'll use it as a fulcrum, and I'm then making it ridge its way across and kick. I need to let it do its job. I should be able to get it to slide without my left hand, and then just weight it. That means I must not stand too close to the lathe to prevent it from swinging. I stay slightly above center. When I say slightly above center, I'm talking about half an inch above center. I'm not looking to be right up here like David Ellsworth does with his grind. He has a different format for doing the inside of the bowl. I am just above center so that I can drop to center at the end. Mike Mahoney goes across level. He uses both the 40-40 and bottom bowl gouge that I designed years ago, but he does go cross flat. Glenn Lucas and I, we go slightly above, and then down to center. That makes it easier to get to center, and I get a better peel cut. So just finishing off that cut. Be careful not to press too hard on the bevel because it's got a 60-degree bevel on it, which means it does not glide across the wood as nice as 40. But across side grain, it doesn't matter about the bevel angle as much. The bevel angle when you were slicing through end grain is much more critical. But you can see there's a little bit of ribbing there, and that lets you know. Let's actually just pencil that in. You'll see that I'm pressing too hard on the bevel. If you can get it to see the marks, should be able to see it. That doesn't show it too well. Anyway, they're there. I can see them. The pencil mark is not showing them up. So what I'm going to do here is not press so much on the bevel. I've got to be a little bit lighter. So a little bit smoother cut, a little bit lighter. So just light pressure, swinging through the middle, slower with the cut. Remember the wood is going slower surface feet per minute in the middle, slowing down, slowing down, slowing down. Now where this gouge is also very good is cleaning up the face. So let's take it square at the face. So we got a clean inside bowl there. That's a rough out bowl, and it's even wall thickness all the way around, about 10% diameter. Let's clean up the surface here where we've got some breakout and what have you. So this tool, again, this is side grain at the top. It's a side grain exposing, side grain finishing tool. So start with nothing. Don't start live. If you're starting square, there's no cut that starts square. So what we've got to do here is find the cut. There it is. Bring it back, and then we can push it across, cleaning up the surface because of this breakout. Like so. Now, do we want to break the edge on this? Sometimes it's worth breaking the edge because this edge, especially with ash, is quite vulnerable to cracking. So here, if you want to, you can just take a little bit of the corner off just to make sure that it's not going to check on us later. A little bit on the corner here. And I'll probably shape this rim anyway. So I'm just killing that edge, and that's going to help with the drying out process. So this bowl blank is even wall thickness all the way around, and that bowl blank is now ready to wax, glue, whatever you want to put on it, and dry out. So, rough out bowl. We'll throw that to one side, and let's take a dry piece and finish up the dry piece and jam chuck it. So here we've got the wet piece of ash I turned earlier, rough out bowl, ready to wax or seal in some manner. and we'll come back to that later on. Obviously in that time it'll go oval, which is what this one has done. This has gone slightly oval. This is honey locust, but it's very dry and it hasn't warped a lot because it's a fairly enclosed bowl. So let's finish this one off, and we'll use different methods to hold it and to finish it as a bowl ready for sanding. So the method I'll be using will be jam chucking, but before I jam chuck I've got to prep it a couple of stages before that. So we'll move this to one side and chuck this one up. So this blank here has its original chuck mark on the back. You can see where it's been driven on. So let's bring up the tailstock. We're just going to use this as a pressure plate. You can put rubber piece of foam on here too. Sometimes that stops a little bit of rattling, but normally it's pretty precise and fits exactly where we want it to, because all I want to do right now is true up the tenon, nothing more. I'm not trying to shape the bowl, putting it on my original drive center mark, which is still there. We can see how much is warped, not a lot, maybe 3/16. I'm just going to clean up that tenon. So all I need is one clean up cut with my 40/40 gouge to cut this tenon back to round, so that we know when we grip it, it's running somewhat true. Okay, from here we start slow. We'll grab the 40/40. So taking my 40/40 gouge, I can cut this tenon in. Doesn't require a lot of material to be removed. We start off slow, see what we've got. So it needs about 1/8 of an inch to get that down to a nice round, clean tenon again. So coming in from the side, small cut, not forgetting to tuck the gouge in at the end of the cut to form an undercut shoulder and a trued up tenon. So we can flip that over and grip that in the chuck. Now, what I'm looking to do here is simply to put a method of gripping here so I can flip it back around and then hold it very securely without using a tailstock. Because I'm using push cut around the outside of the bowl, I need to be able to turn the whole outside of the bowl without the tailstock there. So I've got several options to do this. So let me grab those options and bring them over. So the options are to expand into here with a chuck. So I can use long jaws like these guys, and they allow me to put in a small recess and still give me access to the chuck. So they are ideal. These are extended jaws. These are my Batty long jaws. Or I can go to large diameter, and by using large diameter, I can grip right up near the rim of the bowl, and both of these are suitable. So I've got an option for both. I think in this particular case, I'm going to use the wide diameter, and I'm just going to cut myself a little bit of a step in here and expand my jaws into there. So we'll not use the long jaws on this particular occasion, and we'll use the big diameter. So I'm still able to use the 40/40 gouge for this because it does cut a good recess or tenon. So just cutting in towards the top here, just find myself an area where I can get location with the chuck. And that should do it. We can expand the jaws into that. We got enough seating on there to get a grip on at least 60% all the way around. And we're good, because we're just doing a light cut around the outside to finish this bowl. So I'll mount these onto a chuck, and off we go. So taking the groove we have on the inside here, we'll locate it onto the chuck. Worthwhile bringing up the tailstock for this. So what I'll do is I'll expand this a little bit to get a little bit of location, and then we'll check it with the tailstock. What the tailstock is going to make sure we do is that we're on center, because we're on center before. And we'll bring this in, and then we can find true location here and expand that all the way out into the groove. And that's us running true. So now with location on this and running reasonably true, what we're looking to do is to turn the outside. We're going to just touch up the tenon again, just very lightly, so that we know when we do the inside to be running true. But I do need to sharpen this gouge now because this is an important cut. I'm able to get this down to the round and do a finished cut in one if possible, if I take a big enough cut. So setting my true rest up at the correct height first to ensure that my gouge is on center height. It is. And then we have an option here. We have the option to use the tenon later, which would be a smaller tenon, or to lose the tenon. I have enough thickness in the base to be able to do either. So at this stage here, I can make an OG cut here and then remove this later when I jam chuck. I'll say to myself, I'm going to have a more delicate base, so I'll cut that away again later. But for now, I think I'm going to lose the tenon on this. I'm going to lose about 5/16 thickness, and that's okay. So let's cut the tenon in true now, and then we'll go for an OG cut all the way around. So being an OG cut, it's important that this bevel length is 1/8 or less here. So I may shorten this a tiny bit more so we don't get compression marks off the heel of the bevel as we do the OG part of this cut. And there's enough material here that if I do a heavy enough cut, I could get it in one pass. So let's cut the tenon in first and see what we've got. So let's cut it back into true so we know when we use it again later, it's good. The ball will be running through. So being a 40-40, I'm able to get into the corner and undercut both the shoulder and the tenon. We know that's good. Let's take the heel of the bevel off and make it slightly shorter. So I'm going to make sure it is under 1/8. So I've just shortened the heel of the bevel so that it's under 1/8 right here, so that this length here is very short. And we can go for the cut here. Now, depending on how it cuts, we may be able to get in one, if not it'll be two. So take the speed up a little quicker. So running at 1200 RPM. Set my tool rest up to be able to do both the start and the finish. So let's go for a nice closing cut here. And if it's going to make a one cut, it needs to be slow and methodical. Now this does take practice. If you're not used to this, you may need to do this in a couple of cuts. The wood is very dry. So the cut is the same, but there's a little more resistance and a little bit more heat off the giving. Now here I'm going to be breaking the wool because I'm going to get to the crown of the bowl and I'm going to be going very slightly downhill. So we're going to really close the bevel, or the push it I say, and cut much slower. Slowing down towards the end, slowing down. On this particular occasion, we may have got this in one pass. Let's have a look. Yes, we did. We got it in one pass. So, alright, so on this particular bowl here, we can flip it around and hollow it out. Now we'll need to change the chuck back to our standard chuck, so I'll just flip this one off and put on my 4-inch jaws. Ensuring I've got correct location and that the wood is touching on all 4 jaws before I tighten it all the way. Now here at this stage, see how true we're running? It's running very true. Now, do I want to make a thin bowl, a rimmed bowl? So a rim bowl I would normally do where it's rimmed, where it's got a curvature curving in both directions, and then I'll undercut it. On this particular occasion, I think I'm going to make a thin wall bowl out of this guy. So let's just make it thin. It's a little more challenging in some ways, so we'll go for that. So first thing I want to do is I'm going to clean up the face. I'm going to use my bottom bowl gouge to do that now. So the reason for using the bottom bowl gouge is it's just so much better at cleaning up side grains. So we'll swap out the blade and let's clean that up. So what I'm looking also to do here is my bowl is slightly enclosed at this angle, about 5 degrees in. So I want to angle the face of my bowl in also at about 5 degrees to match that, so that the two are at 90 degrees to each other. So using the bottom bowl gouge, 5 degrees is acceptable. If the angle was much greater, then I would use the 40-40. So here, it's going to start on a bouncy surface, so find the cut, and then work it across. It'll probably take 2 cuts. Get it down to the level, and then putting a nice and slow here. So, and let's just check that area and rim before we move on. It's good. Yep, all cleaned up, no torn grain, sharp edges. Now, changing over to the 40/40 gouge. Now there's enough material here that it'll take several cuts to get there. So what I'm looking to do is make this bowl about half the thickness at the top and take some of the bulk out, but I don't want to weaken it at this stage. If I weaken it, the problem I'll have is that it'll start to flex on me early. Okay, so let's set the tool rest at the same angle as the rim, so we know we're going in at 90 degrees to the tool rest, not too close, because we need to be able to get our substrate onto the tool rest rather than the bevel as we go in. And then we can take our tool bevel around also to match that angle. So our bevel is going to be going in at 90 degrees to the tool rest or parallel with the outside of the bowl. So let's do one cut right now and see what we've got and take it from there. So from here, thumb on the tool rest, fingers clamped. Now once I'm into the cut, my fingers and thumb will rotate and slide back. But initially I need that location to enter. There's the cut. Slide back, open the flute just enough. Let's cut away some of the bowl right now. Here, entering again, see how much more we can remove. Entering, getting the thumb in position. Slide back, open the flute. Do not pull on the fingers, they will make the flute vibrate. It will part the way down. We'll stop there. Now, depending on the thickness I want to make the bowl, this is the stage where I've got to decide how much I want to remove more of the bowl. I think I can remove a little bit more of this, so I can do this cut in one swing. So checking that my wall thickness is even, each of my steps is still even. I'm going to take this and cut this in half, power through the next stage and power through the next stage. But I'm going to use a slightly bigger gouge for that. And the reason for that is simply, so here I'm going to use one of my SB beam shaped gouges. This is taller than it is wide. It is 5/8 wide, but it is 3/4 thick. It has a much deeper flute and it's a laminated gouge. It uses 10V on the inside and the substrate is a very tough ductile material that won't break. So here what we're looking to do is to line our bevel up to the outside edge here. So we want them to be parallel. And what we can do here is we can take half the material away here, power through the next stage, power through the next stage. This gouge should be able to do it, although looking down here there's quite a lot of material. It may end up being a little bit more than I want, so I'm going to take a little bit of that away right now, just so I don't end up taking more material than the size of the gouge. And now from there we can then go for this cut. Now just to make sure everything is good, we'll give that chuck a retighten because there's a little bit more chatter there than I like. So, oh yeah, we got a little bit more tightening. And now we can go for this cut. Now, if the piece is going to deflect, what I'll do is I'll use a paper towel on the outside, use my thumb as support to enter. I'll do it just momentarily till I stop the deflection. But cutting slow is very important here. The slower I cut, then the better I'm going to get a result and finish on the inside surface. So remember, this wood is very dry. Now let's go to a longer handle. I'm going to go to a 24 for leverage. So let's change for a 24. Okay, so make sure I can get to the end of the cut here. So on the end cut, so slightly undercut, getting the nose of the gouge in. We'll make this go some deflection. I've got to cut slow to stop that deflection from getting worse. Nice and slow, methodical cut. Here's the keeping speed. Powering through the first stage. Lower to the end of the game here. Going to re-pick that up. And let's take that in too. Just too much volume in this dry honey locust. The honey locust is very abrasive once it's dry. So we finished the top area in one. We got in about 2.5 inches without any deflection and limited tool marks. But as we came around the corner, because the grain direction is changing slightly to be a little bit more end grain, you can hear the resistance and the volume is getting too great even for this beam shaped gouge. So we're just getting some, so we're just going to go around here a little lighter. As we go around the corner, this becomes end grain, but it's not quite time for the bottom roll back. that's as far as we can go with a 40-40. There's always a limit where we've got to get around the corner enough so we can pick up with the bottom bowl gouge to finish that. And the difference is, the bottom bowl gouge will now be going into the face of the wood and cutting side grain here. The 40-40 gouge, because the wings are back, it does a great job of cleaning up the end grain here and slicing through it. But as you come around the corner, this wing here is now interacting with the end grain because we're swinging directly into end grain. So we swap the tools out, put in the bottom bowl gouge. We'll drop the tool rest down a little bit because it's a bigger gouge. It's a 3/4 instead of 5/8, and we want to keep some upward angle towards the end. I'm also going to touch this guy up right now because it turned another ball earlier. So let's touch it up because we don't want anything other than a clean cut across there. So this is a deep enclosed bowl. So I've got my bevel at about 60 degrees on this, and the relief angle around the outside to shorten the bevel is 40. And so this should get us to the middle before it hits the rim. Yes, it'll comfortably do that. And let's cut that. So now we're not interacting with the end grain, we're going back to cutting side grain. So remembering, grip but no thumb. And standing back at the end of the cut, check we can get there. Right foot forward, so I can lean. When you pick up the cut here, you want to pick a little bit, and then release. Because there's no bevel support initially, then the thumb support. We can work our way across the bottom. Going slightly above center, finishing on center. Remember to decelerate towards the middle. Now at this stage I'm going to clean the chips out because it's an enclosed bowl, they've all got caught in there. So I can then glide off my original cut from the 40-40 and finish off with the bottom bowl gouge. So now, sometimes if the bowl's warped, don't press onto that warpage. You want to glide on the surface and cut yourself a new surface. Because even dry bowls sometimes move. There it is. Now we can work our way across the middle. Reset, I'm going to do that again. There we go. Let's take that in two, because that was start with getting 2 bits to finish with one. Now we're ready for finish cut. Because there's more material on the bottom there, we'll go for one more finish cut. Let's clear the chips out so that we can start on a clean surface. And this time a little bit slower, a bit faster there, a little bit slower cut. So just gliding on the surface, picking up the cut. No control, but vertical cut all the way across. I'm going to take that amount of volume away too, because this wood is so dry and it's quite a brittle wood. And then just skim that last little bit one more time with a gliding cut. Getting above center, till we get to the middle. Going down to get the middle, get that last little bit off. And let's check that out. That's got a good curvature in there. Wall thickness is even. And that would be ready to sand. Now, we do have options on this. We could go to the point where we say, oh, we'll take some of the tool marks out and reduce them even further by using negative rake. So let's talk a little bit about negative rake, a technique I developed many years ago to be able to clean up the surface that got tool marks on it. Not necessarily for removing torn grain, because we don't have any torn grain in here, but there are always tool marks. They're the spiral marks. A little bit of deflecting from the wood because it does flex a little bit. And let's see what the negative rake scraper can do on this. So I'll go and grab that and we'll get. So we can see on this bowl there's a little bit of deflection marks where the bowl was flexing a tiny bit against the gouge. Now these are not torn grain, so these are superficial. They don't go deep and they would sand out with 150 grit without any problems, and a little bit of deflection from me over rubbing the bevel at the bottom there. But I can't feel these marks, they're very superficial, so they would sand out very simply. However, if I want to reduce those further, then I can use negative rake. And I've got two types of negative rake scrapers here. One is a solid blade, which works just fine, and this is one of mine with a replaceable blade. This one's getting a little worn down. It needs a new blade putting in it sooner or later because I've used it a lot. But however, this being a bigger blade, it's a little bit more comfortable in the size of bowl. And we don't need a lot of leverage with negative rake because it's not aggressive. This is not a conventional scraper that's pointing downhill. It is a negative rake. A negative rake has a secondary angle. If you don't have a secondary angle, it is a normal scraper, conventional scraper. And this has a burr. If you were to use a conventional scraper shaped like this on the inside of this bowl here, especially being thin and dense and dry, it would become extremely violent and it would grab and pull this bowl off the lathe or pull this tool into it and shatter the piece. But negative rake does not do that. So we can use this negative rake to go from the top to the bottom and vice versa to clean out the tool marks. We can show that in action in a second. So we'll put away the solid one because this is a little bit short and might not even reach, but this one will. So the overhang ratio needed for this is only 3 to 1, so we have plenty here. We've got 1, 2, 3, 4, 5 with a 20-inch handle, so we don't need the 24. Now, one important thing, negative rake scrapers are sharp in both directions. If I go past center, it's sharp in the other direction, and it will want to flip it. So we only go to center here. So we go from center out or to center, but not past. So keep that in mind. Now, we need to raise the tool rest up a little bit because it was set for the bottom bowl gouge. So we're bringing it up a fraction. So we're on center with the cutting edge. Tiny more, bit more. And a little bit of angled in, but not too much. So what we're looking to do here is, let's see where the bowl is. This has got a little bit of warpage in it. It's got a little bit of warpage on the outside because even dry bowls warp a little bit. So keep in mind there is limitations as to if it's warped a lot, the negative rake will just be trying to make it round again, and it may not be ideal, and it's just time to sand it because sanding follows any undulations, any warping, because sanding in general, when we use a pad or a power sanding, they're soft. Negative rake scraping is a form of abrasion. We're using a burr. This has a burr. It has a burr I've created on a very coarse wheel. I can feel it, very distinct. And negative rake scraping is different because this burr is a rigid sandpaper, rigid abrasive. It isn't actually scraping per se. And so what it does is this rigid burr takes out bumps much faster than sandpaper can. And even though if we use sandpaper, say an 80 grit sandpaper in here, it would leave 80 grit marks. This was ground on an 80 grit wheel and it will not leave 80 grit marks. It will leave a much better finish, something that can be finished with 180 grit quite easily. Now, depending on how much flex there is in the bowl, there's not a lot of flex. Sometimes it is worth just keeping a little pad there. I'm not sure I'll need it in this particular occasion, but we can keep a little pad there because it does require not pressure, but a little bit of interaction with the surface here. So if we feel the vibration, we can just reduce that. It's not going to pull in like a regular scraper, and it's not going to push the wood away like a gouge does. It's somewhere between the two. It's kind of neutral. So let's give this a try. So coming in here nice and light, just feel your way in. And there's negative rake, just a little bit of downward pressure, keeping it stable so you can see it interacting with the surface there, taking out the gouge marks, taking out the high spots. Now this is a 10B blade, so it has a really good light, but no matter what it is, negative rake scraping dulls much faster than any other tool. So you can see it's easy to use. We don't think I need the pad at the bottom, so we'll just come from the top, the bottom to the top, towards the top. Now obviously you don't want to create harmonics, so be light round towards the rim. You don't want to vibrate the bowl because then we're just creating more shatter marks. And let's see where we're at with that. So you can see it's removing a lot of material very rapidly, but it's not creating any adverse effects in here. And it's starting to take out some of the tool marks left from where the gouge was deflecting. Across the bottom is really clean. Let's try the sidewall again. Just to be on the safe side, we still got a burr. If we don't have a burr, we need to put a new one on there. I can still feel it. So I'm just going to use the pad just to be on the safe side so we don't create any harmonics. I'm pressing down with my thumb just to keep the tool stable, and then just lightly gliding on the surface, taking out tool marks. So you see it's removing a lot of material. Now I'm not pushing into the surface, I'm just gliding on the surface. And it likes taking out bumps. It doesn't like bumps because it's a rigid form of abrasive, a bit like a wheel, a grinding wheel. Because it's rigid, it doesn't deflect, then what it's capable of doing is pushing through any of the tool marks left from the gouge. So we'll see one more time and that should do it. So it's very effective at cleaning up this bowl. And was it necessary to use this? Not always. Sometimes your sandpaper will take out the gouge marks just as fast. But in this particular case, it's taken out most of the tool marks, and that would then be much easier to sand. That's really clean. It doesn't tear out the grain as long as it's got a burr. Once the burr's gone, it stops working, and then you start pushing. That pushing creates vibration and can tear the wood. And you can do the same on the outside. So let's grab one and show you on the outside to how that works. So here we have a swept-back negative rake that I used on the inside. On the outside, I have one that's ground straight across. It's also got a fairly low angle, about 40 degrees on this to give me a nice big burr. And the side of the wheel that I ground it on is the side that I placed down on the tool rest so that I've got the burr facing upwards. Now this will work ideal for cleaning up the outside of the bowl here, as long as it hasn't warped too much. You could use a skew as well. It does need to be a double angle chisel. You cannot use a single angle chisel. Here's a single angle scraper. If I use that on the outside of the bowl here where it's all end grain, it would completely grab into that and blow it up. And if you use a single angle on the inside here rather than a double angle like this one, you'd have the same problem. So let's use this one here on the outside. We'll put it in the same handle. Not that we need a handle 20 inches long because the overhang is very short. And let me just check to feel the burr. There it is. So this is not a particularly big burr because I ground this one on a finer wheel, I think a 180 grit. But we can see how this works on the outside here. So from here, I can work part of it from here round. You can see it's not aggressive. It will clean up the surface. Now this bowl's warped a little bit more because I'm doing the inside and the outside. So how much can I take away? There is a limit. So obviously you can see it's not aggressive, it's not grabbing. But we don't want to really reshape the whole bowl here. And this burr will not last indefinitely. Probably got about 45 seconds before it'll start to wear off. So you can see it is cutting this, even though it's thin, it is cutting it, and it's taking off some of the high spots from where the gouge was, where it's warped. But that burr's almost gone, and I'm going to use a coarser wheel to sharpen this one up this time. Instead of using a 180, I'm going to use an 80 to give me a more coarse burr. So I've given this a more coarse burr here using an 80 grit wheel, and I also pushed in a little bit harder on the wheel, a little bit more pressure, and that'll give me a longer lasting burr. So this will work a little bit longer here before it dulls off. Obviously don't push into the surface, let the burr do its job. And we can see it's taking out some of the tool marks and bringing it back to round because it had definitely warped quite a bit. Now this is where normal sandpaper would just follow the shape and just follow it even though it's gone slightly oval. The negative rake here you can see taking up a reasonable amount, but I can't be too aggressive here because the bowl is thin. But we'll stop at this stage and then we're going to jam chuck this bowl, and it'll be more effective once it's jam chucked for a simple reason. So you can see where we've done the negative rake, but part of it is still the gouge. That's how much it's warped. If we jam chuck it, it'll bring it back to true round. We'll get less deflection because we won't get any flexing. So let's throw this on the jam chuck to finish the outside. Obviously at this stage I'd sand the inside, but we're going to skip that stage. So to finish off this bowl, I've got the option of jam chucking. Also cold jaws, but cold jaws would mean gripping around the outside and I wouldn't have full access to the whole bowl. I could also vacuum chuck, but vacuum chucking, if you're making a thin bowl, can sometimes implode. And also there's always a little bit of deflection with vacuum chucking because you're always mounting onto a rubber membrane. So with jam chucking, you've got a solid block that you can turn true to round and then fit your piece. Obviously you want a block that suits the size of the piece, which this one does. There's no point in taking this large block and cutting it down. This I'll keep for another occasion, so I keep a series of jam chucks from tiny little pieces right up to very large, and I select a piece that suits the blank at the time. So we'll put this one to one side and use the correct size. So we can put this straight on our chuck, expand into it, and we've got a very rapid form of gripping. And as I said before, the one advantage with actual wood jam chucking is that it's going to make the bowl think it's solid again. The bowl will not feel like it is thin, and it won't deflect and move anymore on us. So when we do the outside of the bowl, we can turn the whole outside of the bowl again and make it thinner still. So I'm going to do that and show you how much thinner I can make this bowl from the actual outside. In fact, this bowl actually moved a tiny bit. Even though it was bone dry, it de-stressed a bit. So I can see it's warped a bit, and this will actually help to pull it back down to round. So we'll also use out the negative rake on the outside again, just to demonstrate again. But for now, we'll go back to the 40-40 bowl gouge. So taking the 40-40 bowl gouge, let's get this jam chuck, which is off a bandsaw, back to the round. As you can see, it's not perfectly round. It's a little oversized too, so we'll get it closer to the size that we require before we go for the fit. So simply taking it down to the round. We're on a chuck nice and secure. We're good. And let's get that down to the round. I'm going to stop before I get to the end, so just bevel in line, stop, and I'm going to scrape. Flute closed, just scrape that down. There we go. Now, for the final fit on this, we'll need to know where we are roughly, so let's do a quick check now. So we can see that we are, if we take off about 3/8, it'll start fitting onto that. So let's start off by taking off 3/8 with a taper. So about 3/8 with a taper. And let's also true up the face. We've got a little bit of imbalance. That'll create extra vibration that we don't need. So let's level the face of the block too and make sure that we've got rid of any imbalance. So from here, just getting rid of any imbalance. And let's see what we've got. So the bowl is starting to fit on that, so it needs to go down a tiny bit more. It's not quite there. And then I'm going to reduce the amount of taper, because the taper was just to get us an idea of where we're at. So we'll go down a little bit more and a little less taper. Now, we're not going to get the final fit with the bowl gouge because it's not accurate enough. It's a good enough finish, but not accurate enough. So that's going pretty tight on there. But we're going to go one more up with this, because I did take it a little bit more than I needed. We'll go a little higher up. And then our final fit is going to be with a beading and parting tool. I'm using a square beading and parting tool, not a regular scraper. I'm going to use it as a negative rake, and it does have a burr on it. And I'm going to use that for the final fit. It'll let me cut a clean shoulder and a clean tenon. So we can see where the little step up is there. So it's a little too tight, starting to fit. So let's square up the shoulder. And then let's just take this down a little way so it starts to fit onto that. Now, you've got to be careful. A little bit can be a lot, more than you think, and then all of a sudden, you don't have a good fit. Now, honey locust is quite brittle, so don't force it on. You've got to be more precise. Oh, I'm just a little bit loose, so I took off more than I needed. So real simple. We're going to use the side of the chisel to cut sideways. Cut sideways, and then recut that shoulder. So I missed it today, and give it a little bit more taper, and see where we're at. Starting to go. Now it's going to be too tight. By the time it goes up, that's going to be too tight and has the potential to crack the bowl. So let's be careful with that. And I've got that on there quite tight, so we're just going to use a little chisel just to twist that out, because that's pinching really tight. Not being too aggressive here, just a little twist. There we go, just so I can get it moved. That's still a little tight. There we go. So you can see, once it starts gripping, it grips really well. So I have a little bit too much of a taper here, right here. There's too much of a taper. So I'm going to use my beading and parting tool to eliminate that taper. And so that I end up fitting on a parallel surface. This is quite important. Fit onto a parallel surface. So it's fitting about here. So let's just straighten that out a little bit. And like I said, a little bit can be a lot, and all of a sudden it's a loose fit. So we do need to go up against the shoulder on a parallel surface. Remembering my bowl is undercut, so this shouldn't be touching, but let's be on the safe side. Just in case it is touching, let's just scrape some of that away for now, just so we make sure that that's not interrupting anywhere inside the bowl. So I just scrape that away with a scrape cut. It's not a cut at all, it's just a scrape. Okay, let's make sure we got the fit. Still a little bit too loose, so obviously it was touching the front edge, so we'll cut that again. So, like I said, a little bit is a lot. And try that. So it's close, but not perfect. Oh, that's going. There. That's the fit we're looking for there. That's not going to pull off. It's not spinning, and it's brought it back more true to round. Now, what I'm going to do, I'm going to take this down to the same diameter. So just using my bowl gouge, gliding on my bowl, I'm going to cut this down to the round. So now I've got this down to the same diameter. The masking tape doesn't have to bridge any distance. So masking tape, as we know, isn't strong, but it's very good at stopping the bowl from creeping. If the bowl is creeping, it's creeping towards the gouge and off the jam chuck. Remembering the final fit on my jam chuck was virtually parallel. There was virtually no taper on it. So it would have to fall back a long way before it fall off the jam chuck, and then it's got the masking tape as an added support just to stop it initially creeping. And I also put the masking tape on backwards so it doesn't unwind should I catch the lead edge on it. So from here, I'm going to remove the base of the bowl because the base of the bowl here is thicker and in the way than I want, or I've got the option I can say to myself, ooh, maybe I'll use it as part of the shape. But I think it'll end up too small on this particular one, so I think it's best to remove it. Now I know I have enough wood there to do that, so to remove it, important not to cut in towards the end grain. We must cut towards side grain. So let's do that first. So what we're looking to do here is to cut in sideways towards the side grain. The side grain, like the side of the pencil, is in this direction. If we cut in this direction, we are cutting towards end grain, and that'll put the jam chuck and the bowl under a lot more stress. Now, jam chucks are great at keeping the piece running true because we're running off what we already turned, and we can just cut in sideways here in small bites. Cutting in, cutting in. Just small bites, you don't want to overstress it. And just straighten that out. Now here's something we can do here. Because it's a jam chuck, we have the option of taking it off and measuring it again. So as I'm about close to the limit on this particular bowl here, not a lot of space here. So what I'm going to do here, I'm going to go for my finish cut across the bottom. So I need the middle to be slightly lower. So I'm going to scoop a little bit out here. And then what I'm going to do here is pick up on the cut and use my gouge bevel to guide and create myself a little bit of curvature across the bottom. Now going in this direction, I am going a little bit towards end grain, so cutting slowly. Slow cut, methodical, a little bit of curvature. And stopping there. And what that's allowed me to do is to cut in here with a nice little recess. We'll clean that up now. Now what we're looking to do then is to do one more cut around the outside if we want to true it up. So I've ensured that I've created a burr on the top, which also creates a little burr on the side, and I'm going to use that to clean up the base here. So coming across this, undercutting that very slightly, then going in at an angle, I'm using the side of the chisel to create a really nice end grain clean surface. And that's the base completed on this, clean. And then I've got the option of turning the whole outside in one if I want, or I could simply leave it at the same thickness and negative rake scrape to take out tool marks, or simply sand it as is. But let's show the cut where we can go from the top to the bottom. I think it's secure enough that I can go all the way around without the tape on the jam chuck. So let's do that cut with the 40-40. Really important if we're going to do this that we sharpen up the gouge because it's a critical last cut. And let's see how good a finish we can get on this and how thin we can make it going from the bottom to the top. Now, it's already a good thickness, so it doesn't necessarily need thinning anymore, but we're going to demonstrate it to show what can be done. Now, could it be done in one pass? It probably can. The one thing I do have to be careful of is at the very end of the cut, I must stop and negative rake scrape that in, because if I keep pushing through it, I will burst out the top edge. So time to sharpen this gouge and use it for the cut all the way around. So freshly sharpened gouge, not too long a bevel, it's just 1/8 of an inch right at the nose. We can cut from here to the top in one pass, although this is quite an enclosed bowl, so getting the gouge to be able to make it in one, I've got to set the tool rest up just right. I'm at an overhang, I can kind of split the difference a little bit more. So a little tricky to start, that'd be too much, okay, because of the OG, so may have to do this in two, let's see how it goes. So checking my height, we're looking good. And we'll just check the jam chuck. Yep, that's pretty solid. Now obviously don't be aggressive, you've got to cut slow, methodical cut, but this is how I make a bowl thin from the outside. Now I know the wall thickness is nice and even, so as long as I take the same amount off all the way around, I won't have a problem. But if you take off more or an uneven amount, then you can have problems. So let's follow our original cut round. Getting really slow there. Not the ideal position with the tool rest there. A little bit of a compromise. Remember, this wood is very dry, very brittle. Watch the amount of pressure with the bevel, so you hear me reset the tool there. Slow methodical cut, cutting all the way around. Now, going downhill, I'm going to close the flute more. And let's move the camera around for this cut. So since I moved the camera around, I'm also going to move the tool rest around, take advantage of that. Now, it's going slightly downhill, so keeping the cut really slow. Methodical, closed flute. But remember, I'm technically cutting the grain the wrong way, so the slower cut, the better. And even in that time, I can feel the gouge is slightly dull. I'm pushing a little harder than I was before. Getting near this jam chuck, so I've got to slow down, slow down, slow down, slow down. Now there's a tiny bit left of the rim of the bowl here. I'm going to use negative rake to get that last bit. So we'll use the beating and parting tool. We'll put a fresh burr on it. And we'll come in little bites. So just a little bite. Little bite. Just so I don't break out the top. I'm using negative rake going towards the bowl. So I'm cutting away from the rim, but making sure I'm not pushing it off the jam chuck. Just using a negative rake to clean up some of the bowl gouge marks. It's very effective here. Removing some of the bowl gouge marks. Now this being straight across, it will not go into the concave surface here, but that cleaned up the surface with negative rake and the gouge really well. And let's see if we can get off the jam chuck. There it is. So we removed quite a bit of thickness here. We got an excellent finish off the bowl gouge and the jam chuck all the way around. That's now a bowl that weighs just a few ounces and was ready to sand on the outside. So we can put it back on the jam chuck, and that's one of the advantages with the jam chuck. So you can put it back on and it'll be running true again, running exactly true. And jam chucking is really good for that. Obviously you're doing a lot of high production bowls, solid bowls, you would use vacuum chucking instead, but in this particular occasion it worked really good for this honey locust, which is a bit more of a delicate bowl. And we've made it about just under a 1/4 inch thick, maybe 3/16. Could you make it thinner still? Sure. You just do the same process, cut all the way around again, and we are good to let that bowl be finished as it is. Being able to sharpen correctly for wood turning is essential, especially for final cuts where if the cutting edge isn't sharp, you are going to end up with torn grain. On my 7 fundamentals, it's number 3, and it's number 3 because chucking and grain are slightly more important because that's what keeps the piece of wood on the lathe. However, if we don't have a sharp edge, then we need to make sure it is sharp. It reduces the amount of pressure it takes to cut, and then we end up eliminating torn grain. Now we have the option of 2 types of bench grinders here. I have one with an aluminum oxide wheel, and this is a seeded gel aluminum oxide wheel, ideally suited for sharpening high-speed steels or the exotic steels that we tend to use. The CBN is ideal for sharpening exotic steels too, and it gives us a slightly better edge because it doesn't chip the carbides, because CBN, or cubic boron nitrate, is actually harder than a carbide to be sharp. Remembering that the tool steels we use today all contain vanadium, whether it's 1% or up to 15%. The vanadium does tend to chip with an aluminum oxide wheel, but we get a really keen edge with a CBN. Now, choice of grit and what have you, well, that's a different story. With CBN, we can go right up to 600, I believe even 1200 a day. But I don't like to use anything above 320 for my final edge because I find that I don't take off quite enough sometimes with a 600 grit. And so therefore, I usually stick around 320 for my final edge. The aluminum oxide wheel, where it has main advantages is I can get a really coarse edge if I want to do a little bit more aggressive negative rake scraping, or it's really good for shaping because it's a vitrified wheel and it breaks down a lot faster, so it's forfeiting its own surface to allow us to sharpen more aggressively, get a bigger burr for negative rake scraping, or to allow us to shape a tool more rapidly than CBN can. Now there's other alternatives such as Tormex, which are wet grinding, but they tend to be a little bit slow.
And there's also the option to use belt grinding. Belt grinding is exceptionally good, but it tends not to be used that much in wood turning. So I'm just going to stick with these two machines here that are pedestal mounted. I'll talk about the issues when we have to sometimes bench mount a grinder for us, because sometimes without being able to use modular handles, we've got to be able to swing the gouge and we tend to stand in the path of it. But we'll come back to that later. So let's move on to actually selecting some tools that we're going to sharpen on these two machines and show a little bit of shaping, using shaping with the aluminum oxide, seeded gel wheels, and final. In this particular demonstration, I'm doing both bowl and spindle turning, and here I have a combination of both bowl and spindle turning. However, only one of these tools cannot be used at any time on a bowl, which is the spindle roughing gouge. The others can be used in bowl turning. The skew, of course, not as a skew, but as a negative rake scraper. Same with the beating and parting tool as a negative rake scraper. And this is also a negative rake scraper. A negative rake scraper is simply a tool with a secondary angle on the top. This is a conventional scraper. Single angle does not have a bevel on the top. Now, with our gouges, the spindle roughing gouge, the equivalent for that in bowl turning is the bottom bowl gouge I developed over 30 years ago. And this guy here works excellent on the side grain. This is also a side grain peeling tool. These two are both end grain finishing tools. However, the advantage with the 40/40 grind, with the big wing here, have the ability to also peel at the same time. This is the only tool that can both peel and slice at the same time. The conventional scraper, I only use that in one particular situation, which is to form a recess, an expanding dovetail. The beating and parting tool can be used for both spindle turning as a slicing and as a wide parting tool and as a negative rake scraper. The skew in spindle turning can be used for rolling beads, for planing, and for slicing. On a bowl, it can only be used as a negative rake scraper when it has a burr. So negative rake scrapers must have a burr. Now, when it comes to grind angles, these guys here are 40 and 40. So are these two here, and so is this one. The only one that doesn't have a 40-degree angle on it as an actual cutting chisel is the bottom bowl gouge. This needs to have 50 as the minimum, up to 70 as the maximum. Depending on the depth of the bowl, depends on how steep an angle I want. The more shallow the bowl, the more shallow the angle at 50. Very steep, very narrow bowl would go up to 70 as max. Now, wing swept back. These two do not have the wing swept back much at all. This one is completely straight across. This one is back 5 to 10 maximum. This one is back 30. This one is back 40. And this guy here is grounded around about 70 to 80. It's just a very simple scraper, normally only used into side grain, never into end grain. If it's used into end grain, then I hone the burr off. I leave the burr on when I grind it if I'm using it into side grain. So let's show how to prepare these tools. And in this video, I'm going to show how to make the 40/40 bowl gouge. This is an elliptical fluted one-way bowl gouge. And I have a modular handle. Obviously, the modular handle allows me to take away the handle, but most of you may not have that option. So I'm going to show as if I can't take off the handle. Now, this is an aluminum oxide wheel or a seeded gel wheel, and what we need to do is make sure that this is dressed clean. At this moment in time, there is some metal that's been embedded in the front from sharpening with it before, so we need to dress this. Very important about safety is we can't adjust this tool rest at all, either distance or height, whilst the grinder is running, because if it drops into the wheel whilst it's running, it has the potential of exploding. Also, this gap must be kept to a minimum, so this gap shouldn't be more than 1/8 at max, because things get pulled into this gap. Very essential. But let's dress this, and before I dress it, really important that I wear a mask, because this is going to throw aluminum oxide particles into the air, and I'm also going to be wearing safety glasses. Now, to dress it, I'm going to be using a diamond dresser. This is one that's got multiple diamond fragments embedded in this part, and I'll use the rest as a guide or support as I go across. There is a single point diamond dresser available too. That's a little trickier to use, so I'm going to use this one that's a wide section one. Now, the secret is to go very slow and methodical, and this will give off a lot of dust. Then we'll let the grinder stop, and then we'll show you how we're going to prep for the 40/40 grind. So, mask on. Sure the wheels are clear, everything is tight. Now, light pressure. Do not press in hard. We're just gliding across, cleaning this up. You'll see the wheel change slight color. This wheel wasn't particularly clogged up, but we're dressing it. Now let's give it time to slow down. You can slow down by using the other wheel to take the heel off, and I'm just going to do that quickly just to slow this down. So the first thing I want to do is to set the angle. I'm going to use my angle gauge here. Now, obviously you can measure the end result instead, but I'm going to use the 40-degree here. Now, when we use the angle gauge here, it's important that we only touch the bottom curvature here to set the actual angle. And we're going to reset this because I dressed the wheel. So loosen, bring it up, you'll find location, pinch up. That feels good. And then what we want to do here is we want to turn it on its side, and we're going to use the 40-degree and a pen to mark it on each side of the wheel. So this angle gauge is designed to work on flat surfaces too, so you must touch both of these surfaces when you're doing flat. And then I can put the 40-degree line to the side here, and then I can put the 40-degree line to the other side. So again, making sure both touch. And that's a reference point. And what that reference allows me to do, it lets me know that I'm not to swing the gouge past that line. There's occasion times when we do need to, but we don't generally want to. It's a reference point. Let's make sure this is also down and out the way, and fully locked, and fully locked. So from here, this gouge is already correct. So that's too easy to start with. So what I'm going to do is show you how to start from scratch. So I'm going to kill this edge and show you how to take a brand new gouge from scratch and form the 40-degree bevel, which is already set by the angle gauge, but the 40-degree wing. Now to do that, if we put the gouge upside down, that is actually 40 degrees. Now, unfortunately, the wheel is going to create a concave grind because it's convex, and it will create the opposite. So when I push this in, the flute touching here, I'm going to rock it slightly to straighten it out. And that is a gouge that is ready to shape and sharpen. So obviously, if there was more material here, I would be grinding away more. But what I've got here is I've got 40 degrees from the flute up, created by reversing the gouge. So let's give this a touch up. Now you can see I need a little less material here than I do here and here. So I've got to follow what the inside of the flute is giving me. So this is very important. Now, how far over do I roll the gouge? What I'm looking to do is to take this slight curve here and lay that flat or parallel to the rest. So what I'm going to do here, I'm going to put a piece of tape inside here and on here as a reference. So here, just to show this part of the grinding, I'm going to take the handle off. What we're looking to do, I've put tape on the inside, yellow on the inside here, and yellow on the opposite side. Now, this is a form of V-gouge. It is elliptical. So what we're looking to do is that long part of the inside of the flute, we're looking to make that parallel with our rest, which would be parallel with this pencil. If we over-rotate, then we're changing the angle from 40 to whatever angle we rotate it to. So being a V-gouge, we do not want to take it vertical. The flute is slightly open depending on the manufacturer, and every manufacturer is slightly different. And the same on the other side, I line my tape up to be parallel with my rest, and that's as far as I rotate it. And the black line on either side is generally as far as I want to swing it. And then what we've got to do is we can see where I've killed the front edge and made it straight. It is a straight wing. And then it is somewhat of a tight radius nose. So we are going to follow that round. And to follow that round, what we're looking to do is, if we've got a handle on the tool, then what we need to do is place our left hand on top, our right hand up front. We do not want to hold the handle because we'll tend to lift it. Obviously, if you can take the handle off, it's a lot easier. So it's a little bit tricky to balance here, but we don't have to be here for too long. Now, obviously, if I swing back this way, I need to make sure my body's out of the path because we want to get to halfway. We want to get to halfway. Our left hand is keeping the tool stable on the tool rest. But what we've got to prevent is from lifting when we do this, because that'll change the angle. So the platform is a form of jig, but it's not a jig that has too much restriction. So unlike a one-way or a pivoting jig, you can rotate the gouge to the correct position. There's no way of doing this particular grind 100% correct on a jig. It has to be done by hand. So let's fire up the grinder. Now we can see where I've got the most amount. I have a little bit more to come off this side than this side. So let's get that close too. So hands on top. Let's work this back and forth. Now this, I'm rocking it. The reason I'm rocking it is the inside of this flute is curved, and I'm following that curvature. Now if I'm starting to get it hot, I will put it in water. I'm just keeping it cool, not particularly cooling it down, just preventing it from getting hot. I'm getting close, but not there yet. Let's do the other side. Let's rock it. Now this wheel's a lot faster than the CBN. Getting close. Let's do the nose. So just getting it a nice even amount of thickness left. There's still a little bit to go, probably around 20 thou. Let's cool the gouge one more time. And then from here, let's follow it round. So, using the line as a guide, I am rocking down and forth. There's not much twist here at all. I don't twist until I get to the very nose, and then I'm light through the middle. That gets one side done. Let's do the other side. Hands on top. We're rocking here, to making it straight by rocking it because the inside is slightly curved, and then through to the nose. And this gouge is basically done on this wheel. If I wasn't so worried about the edge, then I would just leave it straight off this CBM wheel. But I'm going to touch it up on a CBM wheel in a moment or two. And I've got a coarse wheel on the other side. That's a little faster to take the heel off. I always want to make sure that the length of the bevel behind the nose, not necessarily all the way around, but behind the nose is 1/8 of an inch or less. So let's change to the other grinder. So now I'm going to do the final edge on a CBN wheel for the 4040 bowl gouge. This is a 180 grit, but it is slightly worn, so it will blue the steel if you're heavy with it or you don't keep it cool. This is preset with the angle gauge to give me a 40-degree bevel and 40-degree wings, so the black lines are for my wings here and here. I don't generally want to swing past those lines. There are occasions when I need to. And then with the CBN, doesn't need dressing, doesn't wear down or groove, but it can lose its primary grinding ability over a period of time, but it lasts significantly longer than any aluminum oxide wheel. Now, keeping the handle on the blade, because we can't always have the opportunity of taking it off. So if you don't, you've got to work with the handle. So we want to stand to the left side because I'm right-handed. That way I'm able to place my left hand on top to keep the gouge flat so I don't end up lifting it. I don't want to hold the end of the handle because I can't reach and I'll tend to lift it. Lifting is the worst you can do, so we want to be careful with that. And over rotation is also not good. So remember, it is a form of V, even though it's elliptical. When you see the yellow tape here is parallel with the rest, parallel with my yellow pencil. That's as far as I want to rotate it. I do not want to over rotate it or I'll be killing my wing edge. Remember, we use the wing for peel. We use the nose for slicing. So if we kill the wing, it won't peel as quickly. It makes the tool less effective removing bulk. Now, let's start the grinder up and let's do the left side first. So keeping an eye on the line, I'm going to start to the far side of the wheel. And I'm going to make sure I'm not over rotating. I'm drawing the gouge back as I drop, 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 drop. There's the nose. Then I rotate through. And let's do that one more time because we started from scratch. So we want to make sure that we actually have the whole edge because this is a gouge I only ground very roughly on the aluminum oxide wheel. So one more time, across, across, across as I'm dropping, dropping, and then rotating through at the end to get the nose. That should give us a good wing. Now the other side, starting using the line as a reference, starting on the other side, grinding across, 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 rotating down at the end. Doing that one more time. And this time I'm going to go slightly above the 40-degree line. The one-way gouge with its very deep flute, sometimes you get a little bit of a high spot there. So I'm going to take that out by going slightly above for a moment. There it is, getting rid of it. And then following it round one more time. Nice and slow, light through the center, blending through, because we've already got a shortened heel on this. So that means the steel is shorter here than here. So we want to be lighter. So that would give us a touch-up. In reality, if I was doing this for as a professional and coming over to the grinder to touch this up, I would simply take the handle off en route, walk over, and I would grind rapidly like this. Once round and down, that's one side. Once round and down, that's the other side. Spin my handle on, take the heel off on the other side. And that would be my 40-40 grind, ready to go for bowl turning or for spindle turning. So keeping the grinder going, I'm going to talk about sharpening the spindle gouge. Now, there's a lot of options for the spindle gouge depending on the type of work you're looking to do, but generally I have just a slight round on it and it's still straight wings. I'll keep a handle on it to show us the benefits of grinding if we stand to the left side of this. So instead of going to the 40-degree line, I'm going to go slightly above it. So when I see the line below the gouge. That's the point that I'm going to go to. Same on the other side. So holding down here, hand on top, we're going to start across the wheel, slightly above, going around, and this is a single swing all the time, dropping and twisting, because it is a radius gouge. The flute of the gouge has a radius. It is not elliptical. It is not V'd. Same on the other side. And it's going to grind slightly above the line, going across, down, 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 rotating through, making sure I've got a nice kind of domed nose on here. I don't need it too pointy for most of the work that I'm doing. And then we take the heel off on the other side to shorten it. So this is now done. Let's touch up a spindle roughing gouge. Now spindle roughing gouges come in different formats. This particular one has a slight straight to curvature to slight straight. So it's not too difficult a one to grind, but whenever we get a straight to a curve to a straight, we tend to get a dip where the straight and the curve meet because we tend to stall out there a bit. Now the important thing on a spindle roughing gouge is that we don't over rotate this. We want to keep these sharp corners. So what I'm looking to do here is go from, with tool parallel or perpendicular to the grinder, go from thumb to thumb. If I keep rotating it, I kill that edge, and we do use that sharp edge in spindle turning. So I go from one side, straight bit here, so kind of straight, twist, and then straight. And then go back one more time, straight bit, rotate through, and straight bit, making sure that I keep the nice, clean, sharp edges here. And on the other side, so I can use those. This is ground virtually straight across, usually no angle at all. Swept back because it's designed for straight cutting. And keeping it flat from one side to the other is essential. Make sure you're not lifting it. We don't want to change the angle. And this is how this gouge is touched up. So here I'm going to talk about the V gouge. This is a very straight gouge with a tight radius. We're still going to grind it with a 40-40, but it's a slightly different grind. Because this has an exact straight in a flute here, it matches the exact straight face on the wheel. So when we're grinding this, we're again looking not to over rotate it. So making sure the inside of the flute, which is very straight, is parallel with the pencil. You do not want to rotate this tool over till it's vertical. That is too far. Same on the other side. Do not rotate it over till it's vertical. That is too far. So from here, let's do the left side first, using the line as a guide. Keep the flute slightly open, hands on top. Let's put a handle on it so we can see how to do this with a handle. So I have to stand out the side, out of the path of the handle. Now, I can go back and forth a little bit to touch up this wing. And then when I drop down, I'm very light so I don't hook the tool. We don't want that hook when I grind in the nose. And that gives us this nice straight wing here. And then what we're looking to do is the other side. So reaching over, but without stepping. Don't over rotate. Take the tool back and forth on the wing, just a couple of light times. And then dropping through lightly through the middle, all the way through. And that would give us the other side. So we end up back to having a nice straight wing here, tight radius at the back. And this has already got a short enough bevel at the front. This is something, like I said, I introduced many, many years ago, beneficial also on the inside of a bowl or any concave cut. And that's a 40-40 on a V gouge. This particular one is a Doug Thompson 5/8 gouge. Here I'm going to sharpen a skew. This has about a 20-degree setback from vertical and a 40-degree bevel. I keep it the same angle as my spindle roughing gouge, my 40-40 gouge, which is a 40 degrees in here. So that means it's made of a 20 and a 20. So to set that 20, again, I use an angle gauge, just bringing it up, and this has already been preset. But if you use an angle gauge, ensure you're only touching on the bottom one, unless you're doing a belt grinder, and that's a different situation where you would then touch top and bottom because belt grinders are straight. So we're already preset. We've already got our skewed angle. If I'm touching this up as a skew, then I might consider, after I've sharpened it on the grinding wheel, to hone it. When you're honing it, because this is creating a concave grind, there is location when we place our slipstone over the top that we can sharpen between the toe and the heel. So we can place on here and sharpen across smoothly and across here. But I'm not using this as a skew right now. So ideally, I would just be touching this up and putting a burr on it, possibly to use on the outside of a bowl. So if I'm using it on the outside of a bowl, then when I'm creating the burr, I only sharpen one side and I'll push in to actually create a little bit of extra pressure to create a desired burr. So there's a little burr on there. You can actually see the pencil will lock on it. It's jamming as it hits the edge. It's cutting some of the pencil away. There's a burr on there. That burr is not very big. This is an 80 grit wheel, but big enough to be able to do some abrasion work, and it'll give us about 40 seconds for this size of chisel, being a 10V chisel. If it's an M2 like a Sorby, then you'll get about a quarter of that life. So this is now ready for a negative rake. If I want to make it into a skew, then I would just hone it slightly and take that burr off. The other chisel I used in a demo was the beating and parting tool. So again, I also sharpen this at the same angle, and by sharpening the top, then the bottom, I end up with actually getting 5 burrs on this. And those burrs are useful. There's a burr here on the side, and there's a burr here on the side, there's a burr on the top here, and there's a burr here and here. And you'll see me use those when I'm using the jam chuck. So ground again at 40 degrees, this chisel is ready to go. Now here I've got my swept-back negative rake scraper, but I'm using this at 25 and 25. So this is set at 20, so I'm going to slow down the grinder and reset it at 25 and show you how I put a burr on this. We only ever use a swept-back to the left side, so therefore we never grind the top. So when we want to create this secondary angle to make it a negative rake, we have to do that independently. Then we're not using it as a scraper. So when we grind this side to create that secondary angle again, when it wears down, we're not getting advantage of using the burr on this side. We only use the burr on this side here, because we always sweep from either the top to the middle or the middle to the top of the bowl, going to the left in modern wood turning. So let's set the platform at 25 degrees. So here I have 2 different types of negative rake scrapers. They both function exactly the same. One is a solid bar, or 10V, and the other is a replaceable blade, 10V. On this particular occasion, I'm going to sharpen the larger of the two. It's a 2-inch wide one, and this has got a replaceable blade, double-sided, which means once it's worn out, you can flip it over and use it again. More cost-effective over time, because the blade, being 10V, is an expensive material. This is a solid one, and eventually it wears down smaller and smaller, and you run out of material fairly soon. Now, negative rake scraping means that we have to sharpen early and often. When the burr is gone, it's time to resharpen. So on this particular occasion, I'm going to reset my platform, which is set at 20, and I'm going to set at 25 for this. So obviously don't do this while the grinder is running, especially with the one-way platforms, because they move distance. These are my SB platforms. They stay at the same distance at all angles. However, it is important still for safety not to change while we are running, for obvious purposes. Now, here we're setting at 25. That's it. We are set. And the reason I'm going to 25, this is a 1/2-inch thick body on this particular chisel. And because of the curvature of the wheel being so great, if we were to set this at 20, then this edge gets just too sharp. So sharpening this, we always want to keep a secondary angle on the top, and it's starting to wear out. Eventually I'll need to put a secondary angle back on this, but we never use the chisel in this direction in bowl turning or in spindle turning, because we just don't sweep to the right side. So on this particular occasion, we're only going to sweep to the left, so we're going to put a burr on all the way around. So starting up the grinder, start from one side. I can go from one side through to the other, ensuring I don't lift the scraper, because if I lift the scraper, I'm going to end up getting a burr once, but I won't get it the second time. I can see here the burr is not coming over the top yet. Let's make sure it's there. There it is. I see the sparks coming over the top. And then I check for it. Yes, got a burr all the way around, and that is good to go. That's a swept back negative rake scraper for inside of bowls, possibly inside of boxes. Of course, this is too big for most boxes. And we have a burr all the way around. Set to go. So here I've got my bottom bowl gouge. This is a Doug Thompson bottom bowl gouge. It's a U-shaped, so it's a radius. You can use elliptical too. V is not so good, but this works just ideal. It's got a little bit of the top milled away. And what we're looking to do is put a 60-degree bevel on this, and we have a 40-degree relief angle all the way around. Now, this particular gouge we use between 50 and 70. 50 for shallow bowls and platters, 70 for deep bowls and narrow bowls, but most of the time 60 covers us for most bowls. As we get sharper, we require more swing with the gouge, and it's easy to hit the rim of the bowl. So let's set this at 60, which is somewhere in between the two. So we'll change our platform here. Again, make sure you do switch the grinder off for changing the angle, and we'll set this at 60. There we go, 60 degrees. We'll lock that. And now this gouge, I tend not to bring the wings back very far, maybe it's 5 degrees or so. You'll see that Glenn Lucas takes them back a little further than both me and Mike. We prefer ours back just 5 degrees. The more you bring the wings back on this, the more it interacts with end grain when you're going across the bottom of the bowl. So I prefer them forward, gives you more control, and it's a lot easier to learn. So to get that 5 degrees, what we do is we give a little bit of swing side to side on this, and that'll give us our 5 degrees. The more we swing it, the more we'll give us swept back wings. And like I said, this is a peeling tool, so the more you sweep the wings back, the more it interacts with end grain, and it isn't good when it interacts with end grain. It's not designed for that. It's designed for the bottom of the bowl, the rim of the bowl, inside the bottom of the bowl. That's it. So from here, this gouge has a straight side with a curve in the middle. So straight side curve. We're going to follow that. So that means we give a slight straight grind, we twist, and a slight straight grind. One more time across, and that edge is done at 60 degrees. This, you can see that I've already taken part of the heel off on this on the other platform at 40 earlier. This isn't too long at this stage, it's about an 8. As it gets longer, then I will shorten it again. Remembering it's doing concave cuts, so we don't want that bevel to be too long, and that is ready to go. Here I'm going to sharpen up the little scraper. I used it for the recess, and it's got a 10-degree dovetail angle, which is about the average angle for most dovetail jaws. So 10 degrees at the front, but at this stage this is set at 60 and too steep, so I'm going to reset the platform to 75. Now if I'm doing really exotic woods, then I'll set it to 80, but I'm mainly turning things like honey locust and ash, so 75 to 70 maybe is good. If I make it 60 degrees, it'll become too sharp for most moderate dense woods like ash, oak, elm. But if I'm doing pine, then 60 degrees is fine. Because it's used going into side grain and not into end grain for that particular cut, I'm going to leave the burr on. If I was using it into end grain for any purpose, inside a box or what have you, then I would always hone the burr off. Although rarely would I use a conventional scraper inside a box because it's just too aggressive. So let's set our grinding platform to 75. And we have 75 on angle gauge number 2. So use the angle gauge number 2. I'm going to set this to 75. Set. And then let's bring this in. So just grinding back and forth. Nothing too precise with a 10-degree angle. That's ready to go. We have a little burr on top. We'll leave that burr on. And that's our dovetail cutting or recess cutting little scraper, conventional scraper.